Check, check. Hello, hello, check. Check, check. check. Very good morning, ladies and gentlemen. A very warm welcome, a heartiest welcome, a heartfelt welcome to the third day, final day, and the concluding day of AgriVision 2026, the 8th International Conference on Sustainable Agriculture for Food Security, organized by Society for Agricultural Research and Management in collaboration with ICAR, IIHR, CHAS Bhubaneswar. We are gathered here at a platform where innovation meets agriculture, sustainability meets science. It is my utmost honor to welcome all the delegates, all the eminent scientists, all the researchers, all the participants, and one and all present over here. Last 2 days were full of insightful presentations, technical sessions, plenary sessions. Today also, we are looking forward to have fruitful plenary sessions. Let us begin the session on the compelling theme of sustainable agriculture and horticulture, food and nutrition, and agri-business. Let us start the day with a round of applause. We are having our esteemed chairperson for the session. Let us welcome him with a louder round of applause, everybody. Dr. P. Naveen from ICAR, IIHR, Bangalore. We welcome you, sir. We welcome our co-chair for the session, Dr. S.K. Palai from OUAT, Bhubaneswar. And also we are having as the co-chair, Dr. Mahadevya C. from IIHR, Bangalore. And also the rapporteur for the sessions, both the rapporteurs, let's welcome with a round of applause, Dr. Tanushree Sahu from IIHR, JS Bhubaneswar. And we are having Dr. Tapan Kumar Palai from KBK Jagatsinghpur, OUAT. We welcome our chairperson, we welcome our co-chair and rapporteurs for the session. The first talk is by our co-chair himself, Dr. S.K. Palai from Odisha University of Agriculture and Technology, Bhubaneswar, and he will be talking on business opportunities in floriculture in Odisha. Let's welcome sir with a round of applause.
Hello, very good morning. So, the chairman of the session, Dr. P. Naveen Kumar, he's also my old friend. We are friends since I think 1997 or 98. So, S.R. Das sir, my teacher and co-chair, and Tanusri and Pratibha, my student, and other dignitaries present here. So, So I was given a topic. I thank the organizers because they have given me this opportunity. So I am going to speak something on this business opportunities in floriculture. Actually, there is no science involved in it, but it is all my experience actually. What I am going to share with you. So. It has received. Can you Okay, so I always say that floriculture is a rich man's business. I think you will agree with me because it is a business by the rich people and it is a business for the rich people also. Why? So next slide, please. Why I call it it is business by the rich people? Because this slide is taken from Huma, roughly maybe some 15 to 20 years back. This is probably the first orchid cultivation by a rich person in Huma. So actually, prior to that, I was conducting little bit experiments on this dendrobium. We had also standardized in RPRC about its everything cultivation practices, but at that time we were not very sure that whether it can be taken up commercially or no. But this person, because we were not able to invest that much, but one rich person, he could invest it and he showed that yes, it can be taken as a remunerative enterprise, although the cost is very much. So how much is the cost? Okay, the cost involved is roughly 50 to 60 lakhs at that time. Right now the cost is much more, and again it is grown in a shed net house. Right now people are growing these dendrobiums in poly houses and the cost is much more. So how many persons can invest roughly 60 to 70 lakhs while cultivating this? So therefore I call it as a, and this photograph was taken in Jharsuguda. I don't remember whether Tanusri was taken to this farm or no. Tanusri was taken. Okay. So this is the slide from this Jharsuguda. This person invested a lot. He had one Gerbera polyhouse and one Rose polyhouse also. It was, and the cost involved was to the tune of some 50-60 lakh rupees at that time. Now it is much more again. So coming to this, these two slides actually were taken from net, and the cost involved is also very high. And why I call this is business for the rich people, because we know that common men do not decorate their houses with flowers every day. Only rich people do this. So therefore it is the business for the rich people also. Again, this is our Swaminathan Hall on the occasion of convocation, and this flower cultivation, flower decoration cost roughly 60 to 70,000 rupees. So it is again a costly affair. So then, what I am doing these things right? If it is a costly affair, then what I am doing? So actually, is floriculture profitable with low investment? I will say rather yes. And the first option what comes to my mind, is this hibiscus. Actually, this hibiscus, what I have shown, is always harvested in a bud stage. Hibiscus, very common hibiscus, we grow it in our backyards. Absolutely no investment. Cut a twig or a stem, put it in your backyard, it will flower. No investment, you can say. And the flower, the minimum price of a flower is 30 paisa. This is the minimum price. But in the winter season, the price goes up to 2 rupees a flower. And when to harvest the flower, the maximum amount invested is in harvesting flowers. So when you put your family labor into this business, then there is absolutely no investment. And the flowers should be harvested when they are in bud stage. I have shown that bud stage. So actually, you might be thinking that this came to my mind. No, this idea came to me from this farmer. Actually, he is my trainee. I had trained him during one SCSP, not SCSP, it was skill training. So this person, he was earlier growing brinjal. Then I convinced him that you grow marigold, you will get more. Then he started growing marigold, and for 2 years he grew marigold. So he used to ask me about his problems through WhatsApp. He will send a photo, sir, this is the problem, what should I do? I just give a reply. And for 2 continuous years he cultivated marigold, and later on he didn't contact me. So after again 2 years, I thought that actually his land is near Lakshmi Sagar. Bhubaneswar, somebody is having idea, it is a very valuable land. The acre cost maybe some 20-30 crores per acre. And in that land, he is cultivating marigold. Then I thought, no, he might have sold his land. But then I called him. Then he said, sir, I have switched over to hibiscus. So if you can you see 1-2 hibiscus plants are here. This is the marigold plantation. 1-2 hibiscus plants are there. So it was planted at that time for his household puja. But later on he found that this is more remunerative than marigold. Because marigold, every 4 to 5 months interval, he have to plant it again. But in hibiscus, once he has planted, he didn't worry for 3 to 4 years or 5 years. So he then diverted to this hibiscus. Then I asked, how much you are getting from hibiscus? He told every day he is harvesting 30,000 flowers. Has a plantation of 200 plants, 2,000 plants. From each plant, on an average, he is getting 15 flowers. It is 30,000 flowers per day. And each bud is sold at a price of 30 paisa. So the per day cost comes to 9,000 rupees. It is equivalent to my salary. But I pay 3,000 rupees tax, he is paying not a single rupee tax. 9,000 per day, tax free. And to my surprise, I said, you are supplying flowers to entire Bhubaneswar. He said, sir, I am supplying from Bhubaneswar, that is from Lakshmi Sagar to Kalpana Chowk. Roughly 3 kilometer or 4 kilometer stretch, few shops are there, and that is sold. He said there is a huge market. Then I went to the florists who are getting flowers from West Bengal. One single person said that he is getting roughly 1 lakh birds per day from West Bengal. And there are so many vendors like him also. So then I said, okay, let's train the farmers that way. So then when I go for farmers training, I say you go for this hibiscus. Okay. And one more important thing is that somebody sometimes asked, okay, what if the flowers are not sold? Then I said, it's very simple. I had been to Pondicherry, Srima Ashram. If somebody has visited that, there in Pondicherry, they get one power syrup, a red colored one, that is extracted from this hibiscus. These hibiscus petals are dipped in lemon juice for a day, then it is extracted, mixed with sugar syrup, and served as a beverage. It is very famous. In Pondicherry, you ask for power syrup, they will give this one. And that is very famous. So that means there is absolutely no problem if you cultivate this hibiscus, very low investment and maximum profit. So next, I am going to say this one of the cut foliages. This is Song of India. So actually, in any flower decoration, we are dealing with only flower. We are thinking that flowers are reused. No, here you can see in that arrangement, there are a lot of fillers are there. You cannot see that, but we have seen that fillers they have got a great, very good market. Actually, in flower cultivation, you have to harvest on a particular date when the flower is mature or about to mature. But here, there is no maturity. If today there is a demand, you harvest it. If no demand, you don't harvest it. It is not going to be wasted. Okay. And each twig, can you say what is the price of each twig? Each twig is 5 rupees. At farmer's point, 30 paisa at farmer's point. I am not talking of the market value. I am talking of the farmer's point. So, and it is very easy to grow also. It is very easy to grow. Have a sednet house with bamboo structure or anything. So there you can grow. Another foliage plant which is also very famous, that is Victoria. And the cost of each Victoria leaf is 2.5 rupees to 3 rupees at farmer's point. And once you plant it, at least for 3 years, 2 to 3 years, it will provide leaves without any break. And when there is a demand, you harvest it. No demand, don't harvest. So there is no loss. So I always ask our farmers, why don't you go for this kind of things where there is no loss absolutely? And no maintenance also. Once you plant it, just forget it. Just water them. Have drip irrigation. You can apply NPK through drip. And then you just, there is no pest attack, no disease attack. Very little pest and very little disease. Another thing is marigold, okay. So this is the view of our AICRP trials. So there we were trying, in AICRP trials, we were given a lot of varieties, so many varieties, 20, 30 varieties were given. You try which variety is performing better under your condition and you recommend it to farmers. And every time the farmers, they say that, sir, okay, the crop is good, easy to grow, but we are not getting profit out of that because when the flowers are produced, it gluts the market. Actually, in Odisha, what happens? The marigold is cultivated in paddy land after the harvest of paddy. But when the paddy, the demand is more during the Margashira Masa, that is Lakshmi Puja time. Okay. So at that time, our field is not ready, flowers are not produced. So there is a glut. So I said, actually, absolutely, there is no problem. This, okay, this is another view of this marigold plot. And this person you can see here is Mr. Nanda. He is from OmniActive. He is from a company who extracts lutein from your marigold. And he says, you sell your flowers in the market. If it is not sold, give it to me. But the only condition is that you have to grow his variety. Because the general varieties which are cultivated, which we cultivate, they have less lutein as compared to their varieties. They have got 4 to 6 varieties. You can choose any of them. You grow them, and he has no barrier. That means you can do anything. You just buy seeds from him. Other things are farmers, and you can sell it freely. And if it is not sold, that means even if the flowers are damaged or wilted or they are not in a sellable condition, you sell to me. I think this kind of option you cannot get. And what they are doing, actually they are making pelleting it, converting it to pellets, and they are sending it to abroad. America, they have got laboratories where they extract lutein, and that lutein is used in eye drops. And he said, now the kids and people are using mobile very much, and their eyes are getting damaged, and our lutein is the only answer to that. And therefore their business is increasing. And one more thing, even if that Nanda is not there to help you, you can dry it, you can add it in poultry feed. In AICRP trials, we have found out that if you add this to poultry feed, then the yolk color becomes more yellow. So our next option is lotus. In Odisha, we have got a lot of lowlands where the water is there. Just plant one lotus plant there. Within 3 to 4 months, entire pond will be covered with lotus. And this also I got from that means one of my trainee farmers. He also showed me. He was having a pond, very small little pond of 10 cents. And from that 10 cents per year, he got 40,000 lotus buds. And he sold it at a minimum price of 2 rupees and got 80,000. And you know, in lotus ponds, there is absolutely no management or no cost is involved. Very simple things. And if our farmers will cultivate these things, they are going to earn a lot of money. Next, what is there? One is golden bottle brass. This is another filler or cut foliage, you can say. Same thing. It is a shrub or a small tree. You plant it, just water them and forget it. No pest, no disease, no maintenance. Nothing is required. And you sell the twigs at the rate of 80 rupees per kg round the year. 80 rupees per kg round the year. Absolutely no maintenance cost, no investment is there. Just plant it. The initial investment is there. Absolutely no investment later on. And the last one is Kamini. This is my favorite. This is my favorite. Although I have shown the flowers here, actually the flowers are of no use. Again, the twigs are in demand throughout the year, and it sells at a price of 60 rupees a kg, the minimum price I am talking of. And during the season, particularly marriage season is there, then the price goes up like 150 rupees. In the rainy season, the price goes up. Because in West Bengal, everything is flooded, so the plants die or they are not able to harvest. So this is the most promising cut foliage as far as my knowledge is concerned, and it gives maximum return. And one more thing, if you don't want to waste your land, just put these things on your boundary, on the farm boundary, and it will not take any land, but it will give you a remuneration like anything. So I think that's all. These are the most, the other things are there. These are actually organic incense sticks. These are actually standardized, these protocols are standardized in AICRP trials. And these things actually are helpful for these SSGs, self-help groups, where the flowers are not sold, marigold flowers, dry them, grind them, add it with cluster bean and jigger powder, that is a adhesive kind of thing, and prepare incense sticks. These are organic incense sticks. No chemical is there, and these are not harmful for your health. You can grow with this, and you can go for this organic gulal also. Very simple. Marigold flowers, you just boil it, you can boil it, and then extract the water, and you will get a black water. Actually, it is very pH dependent. Add some alum to it, and it becomes yellow. Then treat it with chalk powder or any powder, then your gulal is ready. Very easy to make. Right now, a lot of flowers are there. You can prepare gulal, and Holi is coming. It will be sold out like hotcakes because they are very skin friendly. They are user friendly. Next, dry flowers. So these are we do with our ELP students. Actually, bookmarks are there. These are good for self-help groups. I am not going for this commercial farmers. It is not useful. And this resin encapsulation, it is also useful for our self-help groups. Dry the flowers, encapsulate with resin and paperweights, and lot of ornaments, a lot of other things can be prepared. And okay, tinting of tuberose. Tinting, you can tint the flowers. You know that colored tuberose are not available, so you can tint them, and you get a higher price in the market. So we have got protocols for tinting also. And last thing, this heliconia, it is underutilized right now, but in Odisha actually. But one stick sells at a price of 50 rupees minimum. So that's all. Thank you. If anyone asks any problem, any question, I will be happy to answer them.
Thank you very much, sir, for starting the session with an insightful presentation. Let us take some questions.
Yeah, very good, I would say excellent presentation. The actual practical points, I mean, he has presented very nicely with the success stories, the farmers, the stakeholders who are successful in this floriculture. So with those examples, Dr. Palaya has covered the spectrum of business opportunities in floriculture. Thank you very much, Raksa. Excellent presentation. Any
Thank you.
clarifications?
Sir,
Thank you.
I would request you to kindly stay back as we were waiting for some of our delegates, but it is not possible to start any auspicious day without seeking the blessings of Lord. Now it is the time for the auspicious lighting of the lamp. I would request all our dignitaries to please do the honor. To mark the auspicious beginning of the concluding day, let us have the lighting of the lamp. Thank you very much, all the honorable dignitaries, for doing the honor.
Thank you. I must thank Dr. S.K. Palai, and we are very, very good friends from starting from the BJP College Plus 2. So it is my privilege to welcome him and also giving this lecture to all the participants. And I request him to stay back with us today with us. Thank you, Dr. Palai. Thank you.
Thank you very much, sir. Now, moving on, we are having some of our participants. Virtually, they are connected with us. Let's connect to Professor Srinivas Rao Mentreddy. He is joining us from Alabama A&M University, Huntsville, USA. Sir, kindly unmute yourself. We welcome you to AgriVision 2026. He is going to present on cold atmospheric pressure plasma improves seed germination, seedling growth, drought tolerance, and nutritional profile of micrograins. A round of applause for Professor Srinivas Rao Mentreddy. So over to you. Kindly share your slides.
Sure. Thank you very much for the introduction. You can hear me all right?
Yes, you are very much audible. Please go ahead.
All right. Thank you. Let me share my presentation. Are you able to see my first slide?
Yes, yes. Please make it landscape. Make it in landscape mode, sir.
Yeah, absolutely.
Share
I'm
the full
trying.
slide.
Okay. How about
Yes,
that? All right.
yes. Over to you, sir.
All right. Thank you very much. I had, since this is like a plenary session keynote, I had added a few slides. Probably it may run a little bit more than 15 minutes, but I'll try my best to keep it within 15 minutes. With that, this is an emerging technology we have been working for about 10 years now. And during my last presentation, I think I had presented our research on core plasma effects on turmeric. And since then, we moved on to microgreens. I'm Rao Mentreddy. I'm the professor at Alabama A&M University. Lam Dong is my graduate student who finished PhD and now working as a faculty at Texas A&M University. And the work I'm going to present today is actually master's thesis work by Shravan Kumar Sanathanam. He's now moved on to do a PhD in biotechnology. Then Naichen Beng and KG Shu, they are my colleagues who work with me on this project. So while we grapple with the pressing challenges of climate change, dwindling natural resources, and a rapidly growing population, we're constantly looking for innovative means of solutions so that we can make agriculture not only sustainable but also ensure food safety. Of late, artificial intelligence, machine learning, drones-based precision agriculture, they have been making agriculture transform the future of agriculture. There is still need for us to innovate and come with chemical-free technologies to improve crop productivity and food safety. So one such chemical-free technology that we have been exploring for over 10 years now is non-thermal uh, or low temperature atmospheric pressure plasma. So what is this one? Uh, Non-thermal or cold plasma or low temperature pressure plasma, atmospheric pressure plasma. There are several names which are similar, and this is considered as fourth state of matter. It is actually a weakly ionized noble gas like helium or argon, or we can also use ambient air or elemental gases like nitrogen and such. And we run electricity through this, the atoms are broken and they spill out all kinds of charged particles, electrons, neutrons, protons, a lot of free radicals. It also includes some UV photons and such. So there are plasma jets, corona jets mostly associated with solar activity, and these are out there in the nature. And nowadays, plasma is being harnessed for several agricultural uses and applications, particularly for seed germination, plant growth, microbial disinfection of seeds and foods and raw foods, so on. Also, enzymatic inactivation or activation, improving the cooking quality of rice, starch, and so on. So if you look here, we had solids, gas, liquids, and gases. These are mainly known phases of matter. Plasma is now considered as a fourth state of matter. This is composed of charged particles, all electrons. There are some man-made plasmas that we have been familiar with, probably we did not pay attention. These are used in manufacturing, lighting, plasma medicine, space propulsion, and so on. There are also natural phenomena that produce plasmas like lightning, sun, earth, connection, astrophysical jets, and so on. There are myriad uses of plasma now. There's a growing list of uses plasma. Some of the main ones would be seed germination and plant growth, irrigation. We've been using an old method for a long time, but now this offers a chemical-free and also a very efficient method of infusing nitrogen into water and irrigating crops using plasma. And of course, antimicrobial activities that relate to food safety and food consumption. How do we do this? This is the method we use for producing plasma. This gas tank here contains either argon or helium, goes through a flow meter, which is maintained at few flow liters per meter. And then this goes into a chamber here. And here this is a box that actually allows electricity to pass through and splits the gas. Okay. So this is also called as the plasma generator or pulse plasma generator. You see here we are providing this red line here is pulse direct current supply, and then as the gas comes in, the electricity breaks up the gas and atoms are broken, and plasma jet comes out here on the chute, and we place the material here on this stand to treat with plasma. Bigger picture of the same thing. This is the plasma jet. It's a non-thermal, and you can actually put your finger right there, and it's at room temperature. So we call it atmospheric pressure non-thermal plasma. So we have a big team here. This is a $40 million project funded by NSF. And I have an agronomist, microbiologist, plant pathologist, food microbiologist, food engineer, physicist, and so on our team. And our is a small sliver looking at plasma agriculture. But we have about 12 universities involved in this project, and they're looking at industrial and biomedical applications. So in our research, we started with turmeric. You see this here is a turmeric rhizome, and we used pulse jet plasma for that. And parameters were 8 kilovolts pulse amplitude, 6 kilohertz of pulse frequency, and 1 nanosecond pulse width. That was output from the plasma generator. So this is the work of my MS student. He's now doing PhD, improving seed germination, plant growth, and nutritional content and drought tolerance of mustard greens. This was project funded by NASA. They were looking for some leafy vegetables that can be grown in space for long-term living in space. So we came up with the idea of mustard greens. Okay, skip this. This is the actual trial. We used mustard greens as example crop out of all the microgreens. Okay, and we subjected these to 0 seconds, which is control, untreated control. Then we had argon, a low temperature plasma generated from argon gas and also helium gas. And all the treatments were like 30 seconds, 60 seconds, 90, 120, 240, 360, and 480. These were the seconds of exposure of the seeds to these two different gas plasmas. Then we looked at germination metrics, and also we looked at plant growth, mainly plant height, shoot weight, or the biomass, and the root length to look at drought tolerance, and then nutritional parameters such as total phenolic content, flavonoids, and antioxidant levels. These are the microgreens. This is a huge industry here, easily grown, and they pack a lot of nutrients, and very short-term crop. In about 14 days, we can get a crop that can be harvested and sold. But a major issue this is lack of germination to start with, gives patchy germination. And then also because of high humidity and temperatures, create conditions for mold and other pathogenic infestations. So microgreens are a candidate crops. They are very considered as crops of the future, and they pack a lot of nutrients, polyphenols, glucosinolates, minerals, essential oils, isothiocyanates. Main reason we selected mustard green was for isothiocyanates, because the space agency said that astronauts lose their focus and mental abilities when they stay too long in space. So isocyanates generally improve focus and mental abilities, and other vitamins and such. So these are highly priced veggie crops that also offer nutritional benefits such as improved digestibility, digestion, anti-obesity, anti-cancer, anti-diabetic oxidants and so on. So these are production costs are very low, $5 to $8 per meter square. My previous speaker spoke about several flowering plants that can be produced low cost and high returns. Microgreens are somewhat similar. And they command a huge market. This market runs in billions of US dollars. Okay. So this is the apparatus we have, produces jet plasma. Sanatanam, student is treating the seeds. We did two types of treatment. One is direct seed treatment with plasma, where we put the seeds in a vial and then treated with plasma. And then we also treated water and grew the plants in petri dishes using the plasma treated water. So results here, germination, final germination, if you see this gray bar, this is the control, had about 80%, but plasma treated particularly with argon, the germination was very high, significantly high, 94% there, 85. But with helium, we didn't see such a big difference. Again, if you look at the mean germination, time to germinate, which seed germinated first. Okay, that's very important. It gives the initial start. In that, again, argon treated seeds, particularly at 120 to 40 seconds and 360. They gave pretty quick germination compared to the control. Helium somehow did not have significant effects. And then we looked at the germination rate, coefficient of velocity of germination, germination index. Again, we saw similar results. Argon treated gave much higher rates compared to the control. Helium, not really worth noting. Okay. So then we looked at the shoot height. Okay. And there were some differences here, not very consistent. If you look at the control, these gray bars, only helium at 60 seconds of exposure gave tall seedlings. And root length was also a little higher, but not so much significant. And then biomass increased tremendously with argon at 90 seconds compared to control. And again, vigor, seedling vigor was also high with both argon and helium compared to control. So again, repeated the trial with plasma activated water. And we saw that treating with plasma activated water actually increased the biomass of the crops. And here helium did better. So the difference here is there is an interaction where when it comes to germination rates, time and such, argon seems to be very active. But when it comes to actual seedling growth, production of biomass and so on, helium seems to be more active. So if you see all these slides here, helium has done much better, particularly plasma activated water compared to control. So these are the actual plants in the greenhouse. See, this is control here. This is helium treated 30 seconds, much better plants. And again here, control versus the helium. You see bigger plants with more leaves, 60 seconds treatment. Then nutrient analysis. These are the methods of sample preparation. We took about 5 grams dissolved in ethanol, and these are ethanol or aqueous extracts that were processed for determining total phenolic content and also total flavonoid contents. And let me see here. And also we looked at radical scavenging activity and also reducing antioxidant power. Okay. So in this plasma activated water trial, again, we had the absolute growth of the seedlings was much higher compared to the control. All those that were treated with plasma activated water had a much higher absolute growth rates. And also seedling biomass was also a little higher. Actually, it's tremendously higher here compared to control. And this slide here is about plasma active water on total phenolic content of mustard green seeds. Again, argon treated had significantly higher levels of phenolic content compared to the control. And there was some difference here too with helium. So both the argon and helium treated seeds had higher total phenolic content. And here, let me move this. Okay. So this is a plasma direct seed treatment and also plasma activated water on the FRAP, that is the antioxidant capacity of the plants. And here we saw helium had significant effects, increased much better than the control. And again, we see at 30 seconds, this is plasma activated water. And then again, another set of treatments where we used argon for 90 seconds and helium for 90 seconds. This is at 30 seconds, these yellow bars. These red bars were 90-second treatments. And you see significant increase in antioxidant power. Same with 60 seconds, you see significantly increased levels of antioxidants. Antioxidants are highly desirable phytonutrients in the plants. These reduce oxidative stress and help better nutrition of this due to microgreens. That's a major advantage of eating microgreens. Okay, slide's not moving. Okay. This is total flavonoid content. We did not see much differences, so we're not going to spend much time. Whether it's 30 seconds, 90 or 60 seconds, they were all same as. So the total flavonoid content was not affected by plasma treatment. But radical scavenging activity, there was some activity here, for example, at 60 seconds of exposure, some differences here due to helium. Sorry, 90 seconds, 60, yeah, 60 seconds, some, but not really noteworthy. And same here with 90 seconds. We didn't see much effect for a couple of treatments here with plasma activated water.
Sir, sorry
It
for the
gave.
interruption. Kindly hold on, sir. Sir, for 2 minutes we are taking a break. Please be there. Ladies and
Oh,
gentlemen,
okay.
on 30th of January, Sahid Divas is observed. Now we are going to mark the auspicious occasion.
Oh,
Can I
okay.
request everyone to please stand for a while? Today on Sahid Divas, we bow our heads in the gratitude to all the brave hearts who sacrificed their lives for our nation. आज शहीद दिवस पर उन वीर जवानों का याद करते हुए 2 मिनट का नीरव प्रार्थना. Thank you very much, everyone. Please be seated. Let's take a moment to celebrate the courage, the sacrifice, and the patriotism. Sir, you have got 15 minutes. Your time slot is 15 minutes. You are allocated 15 minutes, sir. Please go ahead. Thank you very much,
Okay.
sir, for your
Thank you very
license.
much. I appreciate that. Okay, again, antioxidant power here, peric acid antioxidant power. We saw some differences where if these gray bars are controlled, and generally either direct seed treated or plasma activated water treatments, they had a higher antioxidant power. Okay. If you look at all these three slides, one is the first one is 30-second exposure time for argon and helium. As here is 60 seconds, and then this is 90 seconds. So in all these three times of exposure, we saw significant increase in antioxidant power. Okay. So in conclusion, helium-treated seeds outperformed argon-treated seeds across most parameters. Helium seeds combined with helium plasma-activated water showed significant improvements in root length, biomass, and antioxidant activity, particularly at 60 and 90-second exposure times. Plasma-activated water had substantial impact on germination and growth. Helium plasma-activated water outperformed argon plasma-activated water significantly, enhancing final germination, percentage, root length, shoot height, and so on. When it comes to direct seed treatment, argon did much better with the germination parameters of the metrics, whereas growth parameters and nutrients, helium did much better. And helium seed treatment combined with helium plasma activated water is 60 seconds, consistently yielded higher biomass, root length, and antioxidant properties. I've not really described the drought tolerance so much, but what we did is we treated the seeds, we subjected the seeds to artificial drought using polyethylene glycol 8000 at 0, 5, 10, and 15%. At 15%, the seeds never germinated, they all died. It was too strong, the drought stress. But whereas at 5 and 10%, we saw some effects. And generally, when we subjected the seeds to drought stress using polyethylene glycol, the root lengths increased a bit compared to the control. But when we treated with plasma, the root lengths were much higher, indicating that plants tend to invest more in roots and thus increase their drought tolerance. The key here was that generally, when you stress plants for drought, the plants produce root mass at the expense of shoot or biomass. It reduces the amount of shoot biomass and increases root biomass. But in our study, both shoot biomass and root biomass both increased when we treated the seeds with argon or helium plasma and then subjected them to drought stress using polyethylene glycol 8000. Didn't include slides because of the time constraints. I thought it would be 30 minutes. Then we also looked at all the about 15 microgreens. Okay, radish, spinach, buckwheat, cilantro, cabbage, broccoli, pak choy, scallion, fenugreek, and all those. And we looked at helium 90 seconds and argon here 30 seconds. And there were significant interactions between the gas type plasma and the microgreen crop. So we see here radish responded very well to imbibing more water. This is 24, this is I think 2 hours, 1 hour after soaking. And if you see here radish at 90 seconds helium plasma imbibe much more water compared to control or argon. Spinach also responded very well to helium 90-second exposure. But buckwheat, both argon and helium increased imbibition compared to control. Cilantro, again same, both helium and argon increased imbibition over control. And in this case, cabbage, no differences. Helium didn't have any effect, whereas argon and control were about the same. For broccoli, argon treated seeds imbibe much more water compared to helium or control. Pak choy again, helium did much better, and scallion, helium, and argon both almost same compared to control. Kale, again, both argon, any treatment with any of these plasmas increase imbibition compared to control. Fenugreek, no difference. Only mustard, again, both plasma, argon, and helium increased imbibition compared to control. And this is after 24 hours imbibition rates. We saw similar trends. Okay, but they were little diluted because by then the control caught up too, and you see control had higher also rates of imbibition. So first hour advantage is very much there. The expression for this is that when we treat plasma, didn't show the uh, seeds that were seen under scanning electron microscope. We saw that the seed coat is much perforated and allows for more water to be imbibed at a faster rates compared to the control. Same here after 24 hours, you can see changes here because control also catches up. And this is one slide where I wanted to show before. This particular slide is about the drought tolerance. If you look at the picture here, the seed root lengths were much higher when the plasma treated compared to the control. And we saw much percentage increase in root length compared to control was 8 to 24% and increased biomass. So in this case, there is no reduction in shoot biomass when the plant invests in root biomass. Since this is about food safety, I've added a couple more slides on our work on food safety, particularly seed disease. This is seed-borne disease caused by stem phylum Proteusum on spinach seed. So if you look here, the mycelial production here, plasma treated was much lower. The fungus produces less growth compared to control. These were treated with plasma for 90 seconds. And the main difference here we saw was this left 4 petri dishes. You see these dark circles? These are the conidia, the reproductive structures of the fungus. They're much more here controlled. Whereas these are treated with plasma, they were clear. We didn't see much conidia production. So it is affecting not only mycelial production, but also decreasing the production of reproductive structures of the fungus. And then we also looked at Campestris vesicatoria that causes disease on peppers. And this is a seed-borne disease. Here is a control which was not treated with plasma. And these are bacteria that are rod-shaped and fairly intact. On the other hand, this slide on the right is treated with plasma. And we saw that it is modifying the morphology of the bacteria. We can see the structural changes. They are more fluffy and indented compared to the control. And it's also breaking up the cell walls and killing the bacteria. So this is the effect of plasma on seed-borne pathogen, which is Xanthomonas campestris, pathogenic variety, vesicatoria. We also looked at ready-to-eat smoked salmon, where we looked at Listeria monocytogenes. It's a major problem on ready-to-eat cold smoked salmon. And again, we saw that when we treated the meat, the salmon meat with plasma, just let me run this. This is how we treat the salmon. This is the plasma generating machine there, and this is the sample, salmon fish sample. And we treat that for about 10-15 minutes. And the voltage is about 13 kilovolts, 120 pulse rates. This we tried about. This is another master student work. So it gives you an idea how plasma treatment works. So if you see log reductions were much higher in the treated compared to the control. And if you see the reduction in pathogen populations, there's a linear reduction with increase in time of exposure to low temperature plasma. This is the log values of colony forming units. And if you see here, this is the reduction with increase in time of exposure from 0 to 12 minutes. So there is a lot more work which I have not presented due to time considerations, but just give you an idea that cold atmospheric plasma increases seed germination, seedling growth, drought tolerance, and also nutritional content of microgreens. And it also can be used for food safety, for treating seeds against seed pathogenic diseases, and also foods against listeria and salmonella and so on. We also did some work on E. coli, So in conclusion, it improves crop productivity through seed priming, enhance early and faster rates of seed germination, sprouting of rhizomatous crops, particularly turmeric, improves plant growth, yield, and quality. Also imparts drought tolerance. One is by giving the plants an early start, plants grow much faster and bigger so they can withstand drought stress and also weed competition. And also increase biomass and root production both. And in food safety, we're looking at it kills seed-borne and foodborne pathogens, increases food storability over a longer period of time, and does not impact. I didn't show the slides, but we looked at textural qualities and also organoleptic qualities of food that has been either treated with or without plasma, and we didn't see any effect. But in some cases, we saw that the nitrogen content of the fish or the chicken increased a bit. So we are looking at what are the implications of increased nitrogen in those foods. So in conclusion, I believe treating seeds, foods with low temperature plasma or low temperature plasma is a emerging non-chemical or chemical-free technology that could ensure not only crop productivity but also food safety. These are the funding agencies I'd like to acknowledge, and NSF EPSCO and NASA EPSCO. Thank you very much. I hope I didn't go too much over my time limit, but I'm open to any questions.
Thank you, sir. Thank you very much for a very good elaboration on an emerging area. Plasma treatments nowadays, the research is, many places coming out with positive leads, as elaborated by you, the seed health management, seed quality improvement. So thank you for that very informative talk. Thank you very much.
Thank you all.
Thank you very much, sir. Now we have some questions.
Yes, sir.
Yeah, I'm open to any questions.
Sir, a clarification from one of the participants.
Thank you very much for the information. Your any experience with corn and soybean?
Not with soybean, but there is literature out there on several other crops like wheat mainly. There's a lot of work, and I'm not sure. Probably Chinese did some work on on soybean, but most of the work is on food crops. Yeah, other food crops. By the way, some of the universities in India do have this technology. I'll be visiting IIT Tirupati next month, and they will be setting up some collaboration with them. They already are using plasma.
Yes, sir. Thank you, sir. Thank you.
Thank you. If I may add, there also here we are using millet powder flour, treating millet powder flour with plasma. So applications are immense. There's a lot of scope.
Thank you, sir. Thank you.
Thank you. Thank you very much, sir,
Thank
for
you very
your
much.
valuable participation. Moving on, now, ladies and gentlemen, please welcome our chairperson, Dr. P. Naveen, from ICAR IIHR Bangalore. We will be moving on with his presentation. Could we please have the slides?
Very good morning to all of you. You have heard my friend and Professor and Head Department of Floriculture, OUAT Bhubaneswar, Dr. Siddharth Kumar Palai, elaborating on the business opportunities, the potential of floriculture in Odisha, with very good examples and success stories. So on this occasion, I would like to thank Dr. Palai, and also I would like to thank the organizers as well as the head Chess Bhubaneswar, Dr. Gobind Acharya Saab. On our request, they have organized a stakeholders meet on commercial floriculture in Odisha. So some of the stakeholders are here and some more will be joining. So I would request all the stakeholders who are interested in floriculture to make a visit to the Techno Park in front of the main building of Chess, wherein all our IHR, Indian Institute of Horticulture Research, Bangalore, the varieties developed in flower crops were demonstrated, either it is marigold, tuberose, chrysanthemum, gladiolus, rose. So in all these crops, we have developed high-yielding varieties, which we have distributed here, and then many farmers in and around Bhubaneswar, as well as different districts of Odisha, they have adopted many of these varieties. For example, the variety in tuberose, रजनीगंधा, जो हम हिंदी में बोलते हैं, हमारी एक वैरायटी है अर्का प्रज्वल. अर्का प्रज्वल was found to be very good, giving lakhs of rupees to all the farmers pan India, across all locations. In the south, in the east, in the west, everywhere, it was proven that this Arka Prajwal tuberose variety is producing on an average 15 tons of loose flowers, and 4 to 5 districts of West Bengal, Ganjam district of Odisha, Tamil Nadu, Karnataka, many farmers, the socio-economic conditions of these farmers have been significantly improved with the returns from this Arka Prajwal. May I request the organizers to make this presentation? Haji, there is one presentation. I'll not take much time, 5 to 10 minutes give me. Just the varieties, I list out what are all the high-yielding varieties, improved varieties from IHR. So, in addition to Dr. Palai's talk, we would like to promote floriculture in Odisha because there is a lot of potential both in open field condition as well as in polyhouse conditions. So we would like to we at IHR, Indian Institute of Horticulture Research, we are working on all commercial flower crops. We have a division of flower and medicinal crops. We are working on important flower crops, right from the potential crops listed by Dr. Palay. So I would like to show you the varieties, and we are trying our level best to supply the seed and planting material of these varieties to all the stakeholders all over India. So you can write to us for any material or to the the head Chess Bhuvaneshwar. Already through Chess Bhuvaneshwar as well as OEAT as well as the AICRP center, which is located in Bhuvaneshwar, we have been supplying lots of quantities of this seed and planting material of our varieties. Yeah. You can just. Okay, straight away I'll go into the actual message, what I would like to give it to you. We are at Division of Flower and Medicinal Crops, IHR Bangalore. So working on flower crops as well as medicinal crops. So in rose we all know it's the queen of flowers. So सबसे ज़्यादा महत्व गुलाब का है. So because of various reasons, one of the reason is multiple utility. We have loose flower, cut flower, essential oils, and different value-added products like gulkand, rose water, rose oil. So different multiple utilities are there for rose. So we have varieties for cut flower purpose. This is Arka Swadesh, Arka Ivory, Arka Pride. 3 varieties for cut flower purpose, which can be cultivated both in open field as well as in polyhouse conditions. So this is Arka Ivory in ivory color flowers, light yellow, white color flowers. Arka Pride, red color. So these 3 are very good potential cut flower varieties on par with the Dutch varieties. And then loose flower category. In this segment, we have Arka Sabi, very high yielding, up to 30 tons per hectare. And only indication what I would say, we are getting a number of indents for the planting material of this Arka Savi, the budded plants. So we are on an average supplying 4.5 to 5 lakhs of budded plants to all the stakeholders from IHR Bangalore. But still we are not able to meet the demand what we are getting. Very good variety, high yielding, very good quality, no petal shredding, 4 to 5 days of shelf life, useful as loose flower, although it is loose flower, but it is also used as cut flower for various stage decoration, any decoration of any platforms. So another 2 varieties are Arka Parimala and Arka Sukanya. Both are fragrant varieties, highly scented varieties. They are very good for essential oil extraction, setting up of extraction plant and extracting the oils. And also the dried petals are used in different confectionery items, sweets and different eatables, confectionery. And we have 3 more varieties. They are garden varieties. So for any garden, those the varieties which are flowering for a longer duration, so with fresh flowers, they are assets for the garden. So like that, this Arka Kinari, Arka Sharmili, and Arka Sinchana, these 3 varieties are garden varieties, and this material also we have been supplying. Recently, we have come out with one more variety, Arka Veera Raghavan, to honor Sri M.S. Veera Raghavan, a bureaucrat who recently died in 2024. So we have named after him to honor him. who is a passionate rose breeder. They have developed wife and husband a number of varieties, and they have very good collections of roses, including wild species also in their residence at Kodaikanal, Tamil Nadu. So this is very good climber variety, very big flowers, red in color, and that can be pruned to cover any of the structures. So coming to the next important crop, marigold, I think you have seen the largest area in Odisha under flower crops. If you calculate, I think this tops the ranks. We have very good F1 hybrids for the first time in public sector. There are few F1 hybrids from private sector, but from IHR, we are the first among the public sector to come out with F1 hybrids. So Arka Vibha and Arka Shubha, very good yield potential up to 12 tons per hectare, per acre, sorry. And they are also very good for carotenoids, the recovery of carotenoids, like Dr. Palai was talking about lutein and carotenoids. So we have about 3.25% of carotenoids from Arka Shubha. And two more in yellow color, Arka Abhi and Arka Bhanu. So these two hybrids we are given to many farmers in Odisha, Dr. A.K. Das, Dr. S.K. Palai. There are many success stories. I could not add into my slides, and it was the popularity is increasing. We have been supplying these F1 hybrid seed. So OP varieties, we are ready with open pollinated varieties also, Arka Bangara, Arka Agni, Arka Bangara 2, Bangara. So all these OP varieties, these are propagated through vegetative cuttings, and we have been supplying the cuttings of these three varieties. So there are many success stories. Among the French marigold, Jaffrey jo Hindi mein bolte hai, isme bhi do hai, Arka Pari and Arka Madhu. Both are very good for bedding purpose for any garden. This Madhu is bicolored, you can see, high yielding. So there are a little bit agronomic changes. The typical package of practices needs to be little bit modified to suit to the requirements of these F1 hybrids. So as I said, Arka Prajwal, it has got in the total Eastern India benefited a lot, both West Bengal and Odisha, followed by Karnataka, Maharashtra, the both Telugu states, Telangana and Andhra Pradesh. So it has become almost 60 to 70% of tuberose area is with Arka Prajwal as of now. We have double varieties, Arka Suhasini and Arka Vaibhav, which are used for preparing flower bouquets, different guldasta जो तैयार करने के लिए double type का चाहिए था, so that Suhasini and Arka Vaibhav मिलता है. And Sugandhi आपको extraction essential oil extract करने के लिए, plant setup करने के लिए, this has higher oil recovery and higher yield. So we recommend it for oil purpose. So there are many success stories. Next important crop, I don't know, in Odisha, very small area, but in South Indian states, Tamil Nadu, Karnataka and Andhra, for the first time IHR has come out with 5 varieties. So all those 5 varieties were most sought after in these states, and we have been supplying the material. Next, China Aster. China Aster, we have 6 varieties, very popular, both Purnima and Shashank in white color, Kamini pink color, very popular. We have been supplying almost 2 to 3 quintals of this seed every year to different states. So little changes in the agronomic practices. Next important, gladiolus. We have about 25 to 30 varieties developed at IHR. Out of that, we are popularizing, there is a great demand for 10 varieties. So all those 10 varieties we are multiplying. One among them, Arka Aish, Arka Manorama, and Arka Amar and Arka Naveen, Arka Gold and Arka Kesar. These 6 varieties in different colors, so they are very popular. And 2 more latest, Arka Pratham and Arka Ranjini. So these varieties we are multiplying and distributing to the stakeholders. So Arka Krishika and Arka Red, among Gerbera, another important cut flower crop. Both in open field as well as polyhouse conditions, we can take up this crop. So, but polyhouse conditions, people are depending on exotic varieties, either it from KF Bio or Rajan Shine, Florence Flora. But we at IHR, we have come out with these two varieties, Arka Krishika and Arka Red. Both are very good, highly potential for open field cultivation and very high yielding. Dr. Palai, he has tested in this AICRP center. Most of these varieties have been tested, and he has shown in his slides also. So this Gerbera Marigold. So in addition to this, we have technologies for vertical farming of liliums, vertical farming of gerbera, and vertical farming of orchids. We have end-to-end solutions, right from, what is the growing media, what is the nutrition, what is the irrigation, so what are the varieties, right from beginning to end. So we have the complete package, how to take up this vertical farming of flower crops. This lilium and the cut foliage plants. So these foliage plants are also tried, and potted plants. Now it has become a trend to offer potted plants to all the guests. So we have come out with 4 varieties of chrysanthemum pot varieties, and technology for Arka floral agarbatti and Dhoop technology. Dr. S.K. Pala has explained. So here at IHR, we are providing training for this particular enterprise. Anyone who would like to take up this enterprise, making of agarbatti or Dhoop technology, we have licensing facility. We can license the technology. We can we'll provide the training and complete solutions to anyone who would like to start up this particular venture. So we have medicinal crops. Yesterday, Dr. Uma Maheshwari was speaking. So these are very good green manuring crops, which are nitrogen fixing and anti-nematicidal properties, very effective for nematode management. So we have few more varieties in medicinal crops. Thank you very much. I wanted to give you a brief of the varieties and the technologies available at IHR Bangalore with respect to flower crops and floriculture. Thank you very much. Arka is a trademark of IHR. There is a river, Arkavati, flowing just next to Hisaragatta, the location where IHR has been located. So we have taken that Arka from that Arkavati. So that is the trademark of IHR. Any of our IHR varieties will be prefixed with Arka. So that is our trademark. See, intellectual property rights are very crucial, very important. To have revenues, to increase our revenues, to go for systematic licensing, and the ultimate reach of these technologies, these varieties to the end users. So, the traceability, so all that can be monitored, all that can be encashed with these trademarks. Thank you, sir. You can announce the next speaker.
Thank you very much, sir. A round of applause for Dr. P. Nabeen for the wonderful presentation. Moving on, now we are going to have a presentation on efficacy modulation of Momordica carentia, phytocomponents in adult zebrafish, a dose-dependent study using GCMS in silico admit and in vivo techniques. Please welcome Dr. Asasi Nayak from Centurion University of Technology and Management. A round of applause for Dr. Yasasi Nayak.
Thank you, ma'am. Good morning to all the delegates present over here. I'm Dr. Yashasvi Naik from Centurion University. So, on my behalf, my research scholar, Mr. Sanjeev Mahathi, will be presenting the talk. So, basically, it is required for his final submission. So, that is why. Thank you.
everyone. Uh, Good morning, everyone. I am Sanjeev Kumar Mohanty as a PhD scholar in Centurion University. I am pursuing PhD under Department of Zoology, School of Applied Sciences. My research topic on efficacy modulation of Mammodica charantia phytocomponents in adult zebrafish is dose-dependent study using GCMS, in silico ADMET, and in vivo techniques. Here is my contents. Then let's first overview of my topic. In the first slide, in the introduction slide, we have seen uh, one of the industrial toxicant, that is plasticizers, that are actually used in all over world. 70 to 80% all the various manufacturing products like toys, cosmetics, painting articles, PVC pipes, medical wax, plastics in NICU, and by the and the phthalates are actually, there are several groups of phthalate used in all over the world, and out of this phthalate, DHP phthalate is most more used in manufacturing all the products. But 2000, before 2018, DHP phthalate is used 51% in all over world, but by the some reason, DHP phthalate is replaced by DINP phthalate. Now DINP phthalate is used all over world to manufacturing various products. Now the problem is DINP phthalate is going to show much more effect in human bodies, like it is mimic the endocrine receptors, which it helps to accelerate amyloid beta proteins in Alzheimer and Parkinson's like diseases. And now a world, according to WHO report, Alzheimer is the ongoing research project and ongoing disease in 2025. And according to report of WHO, by 2050 it is going to increase, which is ratio about 1:3, 1:3 by 2050. And there are recent, some of the research paper have told DINP phthalate can got effect in endocrine receptors, and also get affected in HPG axis in human body, as well as accelerate the amyloid beta protein in Alzheimer's disease. And my topic is going to show to effect how DINP phthalate is affect any kind of receptor that are actually present in human body, and as well as I have selected my protectant as a Mammodica charantia to helping out and curing and minimizing the disease effect in human body as the model of zebrafish. Then features of Mammodica charantia, as you all know, Mammodica charantia commonly known as bitter gourd, and which has 47 African species and 12 Asian and Australian species are present, which is belonging to family Cucurbitaceae. And Mammodica charantia actually used in controlling the blood sugar and cholesterol level. And there is no several reports present how the Mammodica to treating the neurodegenerative like Alzheimer's and Parkinson's. My aim of the research is that to clarify the objectives. Yes, the Mammodica charantia have some essential bioactive components that are also helps to minimizing the neurodegenerative disease in human beings as a model zebrafish. And by the description of my objective, first we have investigated the neurotoxic effects of DINP phthalate exposures in adult zebrafish mimicking the neurodegenerative disease condition. Then to identify and characterization of bioactive components by the help of GCMS and in silico analysis, and to evaluate the binding affinity and molecular docking as a ADMET property of phytocomponent against neurodegeneration targets like ACHE, and to assess the next is to assess the neuroprotective potential, select the Mammodica charantia phytocomponent through in vivo studies as a DINP exposed to adult zebrafish. And in the last, we have done the behavioral and biochemical assays and source and evaluate the changes and neuroprotective efficacy, the control under treated zebrafish group. Then methodology, first we have collected some samples of on-ripe fruit of Mammodica charantia. Then we extract the oxalator apparatus. Then we done the in silico drug designing. After that, we have done the experimental setup as a model zebrafish, because 70 to 75% genomic sequence is a homology model to as a human beings. That's we are taking as our in vivo model zebrafish. And we have done the behavioral assessment as a two behavioral assessment we have done. One is light and dark box test, and another one is novel tongue diving test. All the experiments have done with the software NMS, and then we have studied the histopathological changes in zebrafish's brain and to evaluate the pycnotic and the cell apoptosis in the zebrafish's brain. Then this is the overview summary, then collection, then extraction, in silico drug designing, and the neuroprotective assay, what we have done, LDPT, NDPT, and TMS. And histopathological study, we have collected the zebrafish's brain to evaluate and to consider as a pycnotic cells. Then results. First, we have done the in silico analysis by taking some kind of gene pools that are actually present in zebrafish body, and then we docked over the DINP phthalate on the zebrafish, all the gene pools, and we have resulted that DINP phthalate have shown much more effect in ACHE, which is minus 8.7 KCL, and then we concluded yes, DINP phthalate can affect neurotransmitters like ACHE in adult zebrafish. Then after that, we have done the GCMS analysis. It is the one polar solvent methanol extraction. We have done the GCMS analysis, and these are the some of the phytocomponents which is derived from the GCMS analysis of Momotica cerensea. The solvent is methanol. And another solvent we have taken non-polar as a N-hexane, because N-hexane is a lipophilicity in structure. And some of the phytocomponents that we have found, these are actually cross the BBB barrier in zebrafishes. Then after that, we have done the in silico ADMETs property. Which all the ADMETs property actually done by Swiss ADME tool, and these are the sum of phytocomponents which is shown the very good physiochemical properties in Swiss ADME analysis, which is based on absorption, digestion, metabolism, and toxicity level. And this is the pharmacokinetic properties. In the pharmacokinetic properties, we have found the quinine is the one component which is which is shown to cross the BBB barrier, and this is the medicinal property and drug likeness property. In the drug likeness property, we have found quinone is the one component which is cross the all the drug likeness property like Lipinski, Bose, Barber, Egan, and Moog, and which is which don't have any violations. And synthetic acceptability is 4.34, which is very good synthetic component for doing next experiment. Then this is the bioavailability ladder of 5 best phytocomponent which derived from the N-hexane solvent. And then these are the phytocomponents which is helps to bind the some of the receptors in human beings and zebrafish. And we have found there are 5 components which have shown the best binding efficacy against ACHE. And quinone is the best compound which is shown minus 10.8 KCl against ACHE. Then this is the molecular interactions against ACHE, and all the instructions and simulations have done by the BioVia discovery tool. And the behavioral assessment, we have several doses of DINP. Then we have tested over the light and dark box test. In the light and dark box test, the principle of light and dark box test, the zebrafish is when zebrafish is in normal condition, it is in dark borrowed animal, it is spend in more time in the dark zone. If it is spend in more time in light zone, that means the zebrafish is going to stress. By the helping of behavioral assessment, we have done the LDBT test by the using DINP phthalate. In that experiment, we have defined the D3 doses, one dose, a lower dose, which is get much more affected in the zebrafish. We have found the three parameters like lifespan and light zone and sensitivity to the light and number of transitions. And after that, we have done the quinone as our protectant over the light and dark box test. We have collected the 6 doses from 5 different groups, zebrafish experimental group, and track all the data by using NMS software. Then we have found the D3 in Q9, the lower dose of Q9 of getting much more effect in the adult zebrafish, like all the parameters passed all the parameters like lifespan in light zone, latency to the light zone, and number of transitions. And then the final experiment, we have done the novel tank diving test. In the novel tank diving test, we have taken 5 groups. One is naive, another one is control, the third one is toxicant, our DINP phthalate, another one is protectant quinine, and another one is protectant plus toxicant, which is DINP plus quinine. And the basic principle of a novel tank diving test is when the zebrafish in normal condition, it is not going to be stressed. It spend much more time in bottom zone. If the zebrafish showing much more time in top zone, that means it is going to be stressed. And here we have concluded the naive group, all the zebrafishes, all the replicas that are actually spent all the much more time in the bottom zone as well as in control, but in DINP phthalate, the zebrafish replicas spent much more time in top zone. And the quinine phthalate, it is showing much more time in bottom zone, but in the protectant and toxicant site, it is showing much more time in bottom zone. That means here we are concluded the protectant efficacy quinone is very high as compared to DINP phthalate. And this is the light and dark box test, and also we have taken the 5 same group, and all the track plot data are conducted by the NMS software, which is having all the experiment in Ravensa University Kotak. And in that experiment, we have concluded that the DINP phthalate is having much more effects in adult zebrafish, like time spent in light zone, latency to the light zone, and number of transitions. And the quinine and DINP group is showing the protective efficacy against the DINP phthalate, like all the parameters, time spent, latency, and number of transitions. And in conclusion, we have concluded the DINP shows much more effect in ACHE receptor, and the quinone is the phytobioactive component from Mamotica cerensia, which shows the neuroprotective roles in adult zebrafishes. And quinone leads the reduction and minimizing neurodegenerative like markers in adult zebrafish. And the future perspective, further research is going to mice model as well as in human model. We have developed AI tools like NeuroX, which it helps to analyze the neurodegenerative disease by the help of videographic and speeching balance. And the AI can also aid pre-detective model, optimize the treatment of protocols, personalized therapy based on individual patient profiles.
Thank you very much. So is it your PhD work?
Sir, part of my PhD work.
So part of your PhD.
Yes, sir. This is
So
one
what
objective.
is your PhD will be in the subject? Which subject?
Sir, neurobiology under Department of Zoology.
Neurobiology.
Yes, sir.
Okay. Very good. It is a well-known fact that Mamotica cerensia bitter gourd is having a lot of medicinal properties, and you have tried to extract those phytochemicals and prove it scientifically on this zebrafish. Thank you. Any clarification?
Sampling, which variety of bitter gourd you have used?
Sir, actually, we have collected bitter gourd from Solsuk Organic Farm, Bhubaneswar. That is organic bitter gourds.
Which variety and now you should note the.
Sir, wild types, sir.
It is always recommended to use a named variety. Wild types, we don't know the composition of phytochemicals, what you extracted, that will be the same across all the varieties. So it's always recommended to use a traceability. That's what we were talking. So when someone would like to go back, so so they can make use of the same variety or same hybrid. Thank you.
Thank you, sir.
Thank you very much, Sanjeev. Well presented. A round of applause for him. We wish you well for your future endeavors. Now, moving on, I would request Dr. P. Naveen sir and Dr. Deepa Samant to kindly come up on the stage to present recognition certificate to Dr. Yashasvi Nayak. Can I request ma'am to kindly come up on the stage to receive it? One more time, let's hear it for Dr. Yashasvi Nayak from Centurion University of Technology and Management. Another round of applause for Sanjeev Kumar Mohanty, boarding talent from Centurion University.
Thank you so much. So this is the work which is being done by Sanjeev, and he is working under me. So this is the research project going on, and now it is under the verge of completion. So on that basis, he will be submitting his final submission. So thank you so much for all the inputs. Thank you. So thank you so much, sir, for all the inputs. Definitely we will include whatever you have said us, that the variety has to be included. Thank you. Thank you so much.
Congratulations, both of you. Another round of applause. Thank you. Thank you very much, Dr. Samant. Thank you very much, sir, for doing the honor. Please be seated. Now, moving on, please welcome Professor S.R. Das, eminent professor from OUAT Bhubaneswar. He is going to present on genetic diversity of indigenous aromatic rice of Odisha and its use for economic development of rural poor. Please welcome, sir, with a round of applause.
Sir, time 15 minutes. Kindly,
15 minutes.
we are running late, so kindly stick.
Good morning, everybody. And the only limitations is the time here, but I will try to complete everything. And the genetic diversity of indigenous aromatic rice for the future livelihood development of rural poor. So now rice is so closely associated in our social customs and traditions that it starts with the sowing of rice, we call it Akhay Tritiya. Then by Raja Sankranti in mid-June, there is completion of sowing. And then the Garbhana Sankranti in October symbolizes the reproductive phase of rice. Nuakhai and Lakshmi Puja coincide with the harvesting of upland and lowland rice respectively. And Makar Sankranti in mid-January is celebrated as a Chaita Paraba by the tribal people of Odisha. And by this time rice is harvested, cleaned and brought to the granary. And there are 4 waves of depletion of genetic erosion in rice that initially during 50s that some 82 research stations spread over 14 states developed 445 rice varieties developed through pure line selection. And it may be mentioned about GB24 a highly heterogeneous native farmers variety which has contributed lavishly in the development of so-called high-yielding varieties worldwide. Not only in India but also at Erie for its excellent grain quality and tolerance to different insect pests and diseases. Then there is a second wave, the wide adoption of semi-dwarf high-yielding varieties, that genetic similarity was there, leading to sharp reduction of genetic diversity. Then the hybrid approach, where we found that nearly more than 90% of the sterility-inducing cytoplasm that we called it wild abortive cytoplasm has been used in the hybrid program, and that also there is also depletion of diversity. Then the fourth one, that increased emphasis of molecular marker assisted backcrossing, and we have used few mega varieties which bring down the genetic diversity as the fourth wave. So the biodiversity, rice genetic resources and their protection, and you will find plant genetic resources at the backbone of crop improvement programs, and the collection, conservation, evaluation, cataloging and sharing of the germplasm is very, very important for the success of crop improvement programs. Now, a total of 2,15,000 rice accessions, 3,000 wild accessions of 21 species of Foragia, 11 related genera are preserved in the Erie Gene Bank. And Indian Gene Bank, NBPGR, New Delhi, holds 95,164 rice accessions that you will find that India has contributed more than 50,000 indigenous varieties to Erie germplasm sources. And similarly in Orissa is considered as the secondary center of origin, and there is a very rich genetic diversity for the cultivated rice. Thousands of rice has been cultivated earlier, even after the introduction of the spread of the high-yielding varieties. And you will find many, many varieties, they are adapted to different ecosystems like rain-fed uplands, medium lands, lowlands, semi-deep and semi-deep water lowlands, etc. And these varieties are now being used for development of the rice varieties, possessing tolerance to different, not only stress, also the tolerance to biotic and abiotic stresses. So the traditional cultivars, the majority traditional varieties are low yielders. They have weak stem, calm, susceptible to lodging, low tailoring ability and poor panicle features. And these cultivars grown for specific traits and stature, panicle feature, yield potential, tolerance to biotic, abiotic stresses, etc. And in recent years, by the spread of the high-yielding varieties, and we find, and these varieties, high-yielding rice varieties, has replaced the diversity of the local adapted farmers' varieties. The loss of diversity and genetic erosion is a serious concern, and therefore, recently the Directorate of Agriculture and Food Production, Government of Odisha, has taken a massive effort for the collection of more than 1,100 indigenous rice varieties still available with the farmers from different districts of the states. And more than 750 varieties are registered as farmers varieties in PPVR and FRA, Ministry of Agriculture, Government of India. These traditional talls are still favored by the farmers in the rain-fed uplands, semi-deep, deep water situations and saline conditions of the state. So despite their low yield potentiality, the early seedling vigor, rapid germination, deep root system with higher proportion of thick roots, superior grain quality, better yield stability and tolerance to moisture stress, submergence and salinity. And some of these traditional stalls like Kala Kartik from Sambalpur district, Saru Chinamali from Cuttack and Puri district, Bayahunda and Ratnachudi in Ganjam district, Karandi in Koraput district, Machakanta, Patani, Baleswar district, and Magura in Puri and Cuttack districts are most adaptable types and are still grown. The traditional rice varieties have been explored, collected, and conserved by CRRI and collected about 1745 accessions of cultivated rice and 150 accessions of wild rice from the Jaipur tract of Orissa. CRRI and NBGR have collected almost all the traditional rice varieties of Orissa numbering 2000 and which are conserved in the medium storage in CRRI and long-term storage in NBPGR. Largely, the quality considerations were ignored in the 60s and 70s. Given for yield and greater yield stability. But when we have attained self-sufficiency and surplus, and the consumers awareness among the consumers to improve and diversity of diets, including quality of rice consumed, this revived our breeding program for the improvement of grain quality suitable for local tastes, international needs, besides high yield and resistance to pests and diseases. The diverse food consumption pattern and taste preference include aroma have contributed the localization of certain varieties in some regions. Grain quality preference, consciousness for centuries encouraged the farmers to select, to cultivate, to conserve the best quality aromatic rice despite their tall stature and poor yield. This process of selection has resulted in a large number of aromatic rice varieties adapted to a wide range of agroecological conditions. So aromatic or scented rices occupied a prime position in the society, not only for its high quality but also because they had been considered auspicious. The long, slender basmati types command highest price due to pleasant aroma, extreme grain elongation and soft structure cooked rice. Accordingly, small and medium grain aromatic rices regarded as a separate class of non-basmati aromatic rice. When you compare this one, both have pleasant aroma and they have the basmati types have extreme grain elongation ability, but here in the non-basmati short boiled grains are elongation is low to moderate, and the aroma is there till for several months. Native areas of cultivations for most of these areas are known and they are referred as the indigenous aromatic rices of Odisha. So indigenous aromatic rices with pleasant fragrance, white color, softness has been grown in different states of the country including Odisha. The Jaipur tract of Odisha is known as a putative secondary center of origin. Cultivated rice in India, Koraput district in particular owns overwhelming biodiversity in rice germplasm. And more than 100 these traditional aromatic rice varieties are grown. The varieties like few varieties for the coastal alluvial plain and the varieties like Vimpudivasa, Karpurakalli, etc., they are common in the plateau regions of the state. And I have made a tabular classification of these varieties and which were available in the different districts. And almost all 30 districts will find these short grain aromatic rice varieties. And this is the best slide. And I tell they are my fair ladies. And while collecting the germplasm from the Koraput districts, and these ladies, I requested them and took this photograph. And probably due to them only, we are now able to collect, preserve, and all our indigenous aromatic rices of Orissa. And now there are some picture of some varieties you will find here, and about 100 varieties. I am not going to tell you the names. And now, as I have told you earlier, this is Basmati 370s is long grain, and the indigenous aromatic rice, they are sort like Tarun Bhog, etc. They are short bold grains. It is both are aromatic, but here it is the amylose content is low there in Basmati. The amylose content is high, and as a result of which, immediately after the rice will be, when cooked, it will be sticky. But if we keep it for a longer time, its cooking quality improves. So I can tell that they have dual purposes of we can use it initially, immediately after harvest for kheer or pudding purposes, but if we'll keep it for some time, then its cooking quality improves. Actually, in 1998, I tried that if the farmers in the northern India, they are getting much profit, rice has been exported, and therefore I made an intention to bring Basmati types rice to grow in our eastern zone. But unfortunately, we find there is non-retention of aroma in the traditional Basmati rices. The traditional scented varieties of the state usually have small round grains without much elongation on cooking, but have very strong aroma under the prevailing warmer climate during grain maturity period in Kharif season. But due to their inherent low yield potential, only big and affluent farmers grow them, and hardly anything comes to the market. And these aromatic types are of local origin, are sold with a price of range between rupees 100 to 150 per kg. And I make a survey in Bhubaneswar that in the Reliance Fresh outlets, that short grain aromatic rice like Gobind Bhog, it comes from Chhattisgarh and it is sold at the cost of 200 rupees per kg. Therefore, there is a continued demand for production, marketing of these indigenous centered rices for the socio-economic conditions development of the farmers of Orissa. So the germplasm collection, it was from 97 to 2000, 2011, and almost all about 100 rice varieties have been collected. And during the seed increase and purification at rice research station, I found very difficulty. And there was a heterogeneity for several quantitative traits. The land races, which even more or less uniform for agronomic traits, they are often heterogeneous for several other quantitative traits in rice, which provided a sort of genetic resilience for their adaptable to varied agroclimatic conditions. And these varieties, they are grown for pure line selections. And the land race have certain genetic integrity. They are recognizable morphologically. Farmers have names for them. Different land races differ in adaptation to soil type, seeding time, maturity, height, nutritive value, use, and other properties. They are generally diverse and genetically dynamic, and such balanced populations are variable and maintain equilibrium with both environment and pathogen, and therefore genetically dynamic. They are our heritage, are the result of millennia of natural and artificial selections. They are the basic resources upon which the future plant breeding must depend. Now, majority of these local centered emit aroma while cooking rice from the freshly harvested crop. However, the scent gets reduced after few months after, and it is lost within 6 months. So I was surprised while collecting that Kalajira is that variety which is grown in all the 30 districts. So when Kalajira is one such indigenous aromatic rices which combines better cooking quality and retain aroma for a longer time as a longer period as compared to the other types. Therefore, the farmers, they accept that one which has a better market value. And Jubraj is another variety, have excellent traditional cultivar which have intermediate amylose content, gelatinization temperature, hard gel consistency, and highest kernel length after cooking. Usually it is 1.71, but in case of basmati types, it is 2.2 and more than 2. Comparable with the best quality rice that Jubraj is compared with the Betis of Spain. And the aromatic collections were evaluated for different statistical and breeding approaches. I'm just tell you that here a simple correlation studies tell that grain yield was positively correlated with the panicle number, harvest index, leaf area ratio, leaf weight ratio, and specific leaf area. Then the panicle number was positively associated with the grain yield per plant. The association of grain yield and grain number was positive, but the associations between 100 grain weight and grain number was negative. Therefore, the best way for increasing yield that we must go for higher grain number and keep the grain size as a random variable. The positive association of grain yield with harvest index indicate that yield is a function of harvest index, and yield can be increased by increasing biomass or harvest index or both. And this is determined by high grain number per unit area, stability in grain number, high grain weight, lower spikelet sterility, thus reflecting higher harvest index and increased yield. This is a very interesting slide. I took 5 quantitative characters, and the yield in the glyph, this is high, moderate, and low, and the panicle length in this glyph, and the panicle number, the right glyph. And you will find when the grain number, fertile grain number increased, then the frequency of the high yielding varieties increased. And when the grain weight was increased, this frequency of high yielding declined. But it is surprisingly, you will find where there is balance association of characters like panicle length, panicle number, grain number, and grain weight, it accommodates a higher amount of genotype, high-yielding genotype here, with moderate grain number, moderate grain weight, and accommodate large number. And usually I tell them, these genotypes with higher grain numbers, they are highly intelligent. And in the socially, with 100 grain weight, they are dull fellows. But here you will find that a majority of people, and here they are congregated in one place, there is moderate expression of all characters. I also tell my students, don't worry for extra higher grade points. And the moderate students, they are successful in life, as compared to the dull student and highly intelligent students in the society. Next. And since grain yield is a complex trait, so we have taken direct and multiple criteria of selection, that is 4 selection indices, 1 character index, 8 character index including physiological traits, and 12 character index including grain yield and physiological states and their component traits, and 19 character index including all the traits. And you can see here, when we have compared with the yield, grain yield per plant. The Tulasi Fulla is the yield is less, but yield was more, but in index scoring it was less, and vice versa. Ganjai Kalli, and here it is 10.09, and the plot yield level is very high. And surprisingly, we find Ganjai Kalli is very rich in zinc and iron, and it is a short grain aromatic rice varieties that can be exploited either in cross breeding or the molecular breeding, so on and so forth. And then we have made a D-square analysis, the clustering all the 65 genotype to the different clusters. Then the 40 were found in cluster 1. That tells us grouping of large number of varieties in cluster 1 might have resulted due to identical ecological conditions and similar selection pressure favoring identical expression of characters during course of human selection. And the stability parameter is based on Everhart-Russell model, that is the regression coefficient and the deviations from the regression. And when B is greater than 1, this below average stability, one variety is there, B is less than above average stability, plagiaria is there, and B is equal to 1. And deviation from not significantly different from 0 average stability, they are adapted to different conditions now. And the group 4, B is equal to any value, and a square deviation from regression is significant, they are unstable. It is very interesting, that's why unstable means Achar Mati, and it is adapted to Bhavanipatna area. Lilavati is only adapted to the coastal plain. Gangavali from Ganjam, Vatsabhok from Balagiri, Khusakani and Pipudivas from Keunjhar. That means it indicates these unstable genotypes, they were grown on the native area of their cultivations. Although they are unstable, if you take them to different situations, you will find they will be poor yielding, but a very, very specific adaptability on the native area of their cultivations. Therefore, in the analysis, it is unstable. And no definite trend of relationship is suggested, that generally longer panicle length, higher panicle number, moderate to high grain number with improved spikelet fertility, and so on and so forth, the higher total dry matter productions at maturity is responsible for greater stability of performance. These characters may serve as the basis of yield vigor and could be utilized as important selection criteria in the development of the varieties for greater stability and better adaptations. And here the optimization is important. These varieties were evaluated at N1, N2, N3 as 30 kg, 60 kg, and nitrogen level. And this is very surprising. If you see this one, the table here, most of these varieties, they responded both in N2 and N3 level, that is 30 kgs and 60 kgs. But the response was higher in case of the 30 kgs. Therefore, why we will go for 60 kgs of nitrogen, which they can be successfully grown at 30 kg. And varieties like Acharmati, Lilavati, and they produce superior grain quality than the other entries. And you find the semi-dwarf varieties, which was paired as variety 7, they have a linear yield level, linear yield response to nitrogen, unlike the traditional tall varieties which responded better at low level of nitrogen, can be exploited also for organic farming. Now, these varieties through pure line selections has been developed. This is Kalajira jointly by Voivati and CRRI, and Dusra, Nua Chini Kamini from CRRI, and Nua Acharmati from Voivati. And this is Ketki Joha, and and CR Sugandhan 907 through crossbreeding, making use of the short grain, short bold grain, some varieties has been also developed. And now the estimated marketable surplus and deficit of rice in Odisha, and mostly we have surplus in rice production barring those years where there will be drought or flood or cyclone. And therefore now people are talking that there must be diversity, there must be, we should not grow rice, and it must be with other crops it can be grown. But as far as the climatic situation is concerned, there is high rainfall, we cannot grow anything except rice. Therefore, I suggest why this one, from that we will diversify rice. In spite of high minimum support price, farmers fail to recover the cost of production in the existing market infrastructure. Therefore, there is distress sale, and the diversification of traditional to scented rice cultivation in the state is the requirement. Therefore, efforts should be made for promoting multiplication, distribution, and of these varieties. And now that with starting with only 0.25 quintal of nucleus seeds, that within a few years it will be planted, that we will produce 7,500 quintals of certified seed, which will be planted in 10,000 hectares. And here the economy tells that when the breeder seeds will be there, the net profit will be 42,000, and foundation seed 30,000, and certified seed 20,000, and the average production of calculated aromatic rice 25 to 30 quintals per hectare. Total production cost, we say around 20,000 rupees, and gross income is about 37 to 45,000, and net profit will be 17,000 to 25,000 per hectare. So, future concern and opportunity, and the indigenous types like Dubra, Durgabhog, etc., still some of them are known for their distinct quality features like kernel elongation, volume expansion, head rise recovery, and the combined yield attributing traits. The entire range of these quality traits of these groups of germplasm are neither exploited nor utilized for genetic enhancement of yield as well as quality. So far, the efforts were made in collection, maintenance, evaluation of such indigenous rices is very meager. Therefore, there is a need of well-organized research effort for the collection, purification, characterization of such germplasm still available with the farmers for their future use. Majority of such as are strongly aromatic, retain aroma in a relatively warmer climate. The local type Kalaji rice available in many parts of Orissa can retain aroma for a longer period, even under storage, and therefore have a better market demand. The chemical characterization and quantification of aroma, there is also need for genetics of aroma, quality traits, etc. Limitation of genetic enhancement of yield and quality is due to complex breeding behavior of quality traits, environmental effect in expression, and intergroup sterility. So impose restriction in bring together the complete array of quality. And this can through innovative breeding and selection approaches like disruptive mating, recurrent selection or population improvement, or male sterile facilitated recurrent selection, we can make improvement. And they are my revered teachers. He is Professor E.A. Siddiq. He was my guide at IRI. He is Professor H.K. Mahanti. They are not there. But I learned the art of plant breeding from him. And Dr. Siddiq was students for his life. And at any moment I was reaching him. A new emerging problem and solutions were given. And at working at ERI, I have got the opportunity to work with the Sabuan man, Dr. McKill, and we have developed now the varieties tolerance to both submergence and stagnant flooding. This is harvesting joy, which is a gentle reminder that life is a cycle, that what is sown, it must be reaped. Advice to the next generation's plant breeders: while there are indeed many difficult challenges ahead in the 21st century, but it is important to remember that only 1% increase in the widely grown varieties will have a tremendous impact. A sound theoretical knowledge coupled with considerable hard work, long hours in the field are the secrets of breeding success. And this is likely to be the case for many years to come. The success and sustenance of rice breeding tells there is no easy way to improve rice production. It demands patience, dedication, continuity, and a total mental and physical commitments to field work. This picture is a true picture. While making selection, this black teeny bird at the time of Corona, when I was making selection in the field, this came and sat on my cap. In spite of all the efforts, it was not going. And probably it was telling my dear old friend, and don't stop with work. And even you are 75 years old, don't stop working. And plant breeders therefore never retires in life. Their stories remain untold without you all. My best wishes and kind regards. Thank you very much.
Thank you very much, sir. Very exhaustive presentation. You have added all your experience and your varieties, your achievements, and very good advice to the upcoming breeders. Thank you very much, sir. Thank you, sir. So with this, we have completed our invited talks. Now we will move on to oral presentations, selected oral presentations.
I request you to please come up on the stage to felicitate Professor A.S.R. Das. And also, I would request our co-chair, Dr. S.K. Pallai, to kindly join us on stage to felicitate Professor A.S.R. Das. Thank you very much, sir, for your valuable participation. And that was absolutely an excellent presentation. Thank you very much, sir. Before we proceed for the next session, I would request you to kindly felicitate Dr. S.K. Pallai, sir. Can we hear for Dr. S.K. Pallai, the co-chair for the session? Also, he started the session with his presentation. Rest of the certificates we will be giving in valedictory ceremony. Otherwise, you can collect from the registration desk. As we are running late, we are not taking any tea break. There is 15 minutes slot for the presentations. Moving on, please welcome Dr. Nihar Ranjan Nayak from Regional Plant Research Center, Bhubaneswar, and he will be talking on scope of commercial cultivation of orchids in Eastern India. Please welcome Dr. Nihar Ranjan Nayak.
Sir, now we are running late. I would request you to restrict to 10 minutes, sir.
Hello.
Okay, thank you very much. One last word told by Dr. Das. Those who are planning it, they never reach their track.
morning all. Myself Dr. Nihar Ranjan Naik. I'm basically a botanist, hardcore botanist, but plus that Regional Plant Resource Center. All of you or many of them might be knowing. Regional Plant Resource Center belongs to Forest Department, Government of Odisha. But they do a lot of ornamental works, ornamental plant what they do. They have the best collection in the cacti, roses. Dr. Palai, Professor Palai was there. He started his career. And we are known for the cactus and roses in the country. Wide range of collections. We are helping also different entrepreneurs in that regard. And Dr. Palai actually started the orchid program in RPRC. And I joined in 2012. I took it forward. And you know, basically I'm a hardcore botanist. I don't know anything about agriculture. But our department always says, you have to connect to the people. You have to connect to the farmers. And since I am having 30 years experience in orchids, I thought let me connect with the people. And Dr. Palai also helped me a lot in my connect to the farmers of the state. Next one. Yeah, I don't like to spend my, must be knowing why the orchids are mostly important. The major values are the ornamental values. They have also used as food. They are also having high medicinal values. For your kind information, in Odisha, so far 151 orchids has been identified. And out of those, 8 are exclusive to the state. What does it mean? Means that the climatic condition of the state, it is highly ideal for the cultivation of the orchids. And these are the basic biology. I'm not going to go. And these are the different kind of orchids you can see. Some are the ground, some are epiphytic, some are lithophyte, some are also saprophytic orchids. And these are some of our collections. We started, then what I requested the Rashtriya Krishi Vikas Yojana. They gave me 4 crores of rupees. Then I started call ornamental orchids in RPRC. Some of the collections, we are having around 300 different varieties of orchids collection in RPRC right now. And these are some Phalaenopsis also blooming in RPRC. And some of the Cattleyas also, we have very good collections of Cattleya right now. Fortunately, this year they bloomed, excellently bloomed this year. We have all collections ours we have having right now. And some of the Bhandas also, like that we have around 50 varieties Bhanda. Some of the Ascosenda, it is a hybrid orchid of the Bhandaceous group. And these are also some of the Macaras, we have the collections in RPRC right now. And some of the Plathogonic terrestrial orchid, you can, for your garden decoration, you can use it. And some of the bulbophyllums, it bloomed in RPRC. They are having good ornamental value, but majorly they are used for medicinal purpose. And some of the cymbidiums, if you go to in Odisha, we are having 2 naturally growing cymbidiums, but if you go to northeast areas, the cymbidium values are really high. 1 sticks cost around not less than 1,000 rupees. That's a tremendous scope for the farmers. That's what we're doing right now, although not initiated in Odisha. Recently, we have a MOU with NRC Orchid in Sikkim. We are going to some pockets in Odisha where the temperature goes down below 10 degrees Celsius. We can try few patches whether they are performing well or not. And you can see some of how the cymbidiums looks like in Sikkim. Last year, the flowers show in Sikkim, orchid flowers, and this is the photograph of that. And these are all Sikkim collections. Of course, these are Asian origin, the hybrids are from Netherlands, and they have to keep up the whole world market right now. And as you actually know, the orchid, they adopted different steps. We call that the dancing lady orchid, oncidiums. They're also performing well in Odisha, but you can use as a potted flower. And some of the lady sleeper orchids also not doing very well in Odisha climate. If you can put in a cooler climate, they can also grow very well. And some of these bulbophyllums, monkey-shaped orchids, bark-shaped, these are the different diversified orchids. Then what do we do actually now? We started learning how to grow orchid in a commercial scale, either as a potted flower or as a cut flower. Last 6 years, we have standardized all these steps and technology, how to grow the dendrobium orchid for cut flower production in the state of Odisha. We have thoroughly standardized each and every step. I am really grateful to Dr. Palai. He has helped me initially to stabilize the whole. He was our guide kind of things, and he confirmed we used to, any problem I'm facing, I used to call him for settling down. We wrote a book right now. It will be distributed to all the farmers of the state. Of course, it's written in Odia. And this is the variety actually we are going for commercial scale. It is known as Dendrobium ersacol. It is a hybrid originated from Thailand. It is actually kind of secondary hybrid. The major attraction of this variety is it will bloom around the year in our coastal climate. During the winter time, it may little bit slow down. Each plant can produce minimum 5 blooms in a year, and the farmer can sell 20 rupees per bloom. If you go for a commercial cultivation in an acre, as per the recommendation, 40,000 plants you can grow in acre. And my student is Robbie working as a consultant to the farmers in Odisha right now. They're able to sell 40 lakhs of rupees per year from 1 acre. Means, and the total expenditure, if you go for 1 acre, it will be around closer to 1 crores. And you get 70% subsidy on that. NHB provides 50%, and our state government is adding another 20%. Then you get the money returned within 3 years. That is our statistics. And that's why what we did actually, we started grow ourselves so that we can understand better the crop. We can understand the requirement. We can standardize the fertilization. We can manage the insect, pest, and diseases. Again, we are taking help of the OUT always. Some of the retired professors are associated with us. And you can see this, how the blooming quality is there. And this year, perhaps we already, from a small place, already we are selling out 3 lakhs rupees flowers in RPH itself. And what I like to show you that area, that was a long story, that is in Huma. What they started actually, it was not a protected cultivation, means not in a poly house. And you know the rainfall is very high in Odisha, particularly coastal areas, totally damaged the crop and affected the flower productivity. Then first time we suggested to the Colonel Mahanti, who is a good producer in flower in Bhubaneswar right now, to make it a poly house altogether. 1 acre, 1 poly house, you can grow 40,000 plants, and there you can manage your prevent insect entry, other things you can manage properly, and it's helping everybody right now. That's why in Bhubaneswar itself, Bhubaneswar periphery itself, number of growers are growing these cut flowers, and all are having poly houses. And this is after the construct the poly house, and these are all epiphytes. You have to grow only on coconut cells. This is the best method, you can use it. And these are what we did. Actually, most of the commercial farmers, they are doing 1 meter distances. What we did, we combined together 1 meter beds together so that you can accumulate more plants. And the recommendation is the spacing between the plants is 20 centimeter. But here, what I found it out, the plant is not getting some space to grow. That's why we are making a 30 centimeter space. And I believe our flower quality is becoming more as compared to high density planting. And these are the different how you grow, the initial stages of these things. And you can see this is after 1 year of cultivation. Then it will come, you see how it is blooming in RPH right now. Beside this, we have standardized methods for the 2 white varieties as well. We call it Singapore white and Shannon white. They are performing better than this Sonia variety in Bhubaneswar in Odisha climate. But unfortunately, white demand is not very high. You know, we are using mostly our death rituals and other things. But people like to grow mostly particularly this one. Tremendous demand on the flower right now on the market, this And these are the white varieties what we standardize also in the polyhouse condition in RPRC. And you can see the root structures, everything, how it is developing. And with our fertilization, that's why we have a very good standard method already. We standardize that one. And see how we are harvesting the flowers and selling in the market. That's why starting from the seedling to packaging, everything we standardize, each and everything standardized. You see how we are harvesting in RPRC right now. And these are the different packagings. And also this is the, I wrote in Odia, I thought most of the farmers will be attending today. I wrote in Odia, this is the completely the fertilizer system we standardize thoroughly. And these are the initial stages when it's blooming, different seasonals, we have to do different schedules are there. Then what we do actually now, in collaboration with NRC Orchid, we discussed and found the literature. These macaras are having tremendous demand in the market, and you can use for cut flower production. And very soon, recently I had a discussion with the Rashtriya Krishi Vikas Yojana, they are going to support it more. And we are going to initiate this in Odisha. And first time we are going to standardize in RPRC, then we can transfer technology to the farmers of the state. Anybody like to grow macara, you can see how they are growing. This is the picture of the Thailand, not of mine. And these are, demand is very, very high right now. And you can grow, see how you can just spread the coconut cells on the floor, and you can dry up the plants. Also, you can grow on the raised beds. If you are having waterlogging problem, anything, you can also grow on the raised beds. These are the high-scale production macara. We are going to standardize in RPRC soon, maybe next year like that. And recently, our forest department itself, after they have seen our work, they gave me another 6 crores rupees. We are building a 1 acre, a greenhouse 1 acre. And so that you can have a controlled environment, so that you can have a better quality flowers. We are going to have all the dendrobiums, 150 dendrobiums we are bringing from Thailand. We will have all cultivation practices standardized in that greenhouse very soon. And yeah, these are the again same things. And this is the Phalaenopsis actually, this is the major market in Europe and America. Still, when I was in 20 years before, the cost was $35 a piece of this Phalaenopsis. Recently also around $40 a piece. If you go to any grocery shop in Europe and America, you will find this flower. And the large scale cultivation is happening in some of the Asian countries, but our climate is not very good. Some part of where the temperature is down, coming down below the 10 degrees Celsius, you can start the cultivation of these varieties. Because unless the temperature going down 10 degrees Celsius, they are not going to bloom. You need otherwise you can, now the people are in Kerala, what they're doing, having a cooling air conditioned chamber. You can put the plant for 1 month, they will start bloom. There in Kerala, that Rinko orchid is able to supply around the year these blooms. Whenever you ask any piece of it, they are able to supply the flowers. And these are the basic things we are going to try in Odisha in the future. Basically, as I told you, I'm basically a botanist. I like to grow plants under tissue culture conditions. For kind information, orchid cannot be grown without tissue culture, because the seeds are microscopic, very small in size, non-endospermic. You need to supplement the food through tissue culture system. In RPRC, we have standardized not less than, these are the things, some of the I don't want to spend because time is not there. How to grow, how to plant, in your backyard, in your garden. What are the potting medias, everything we have standardized thoroughly for number of orchids. And this is we started also some breeding work. We have this, our new variety also. We are going to 2 species, Splathogotis plicata and Camellia, and some breeding program already initiated at RPRC. And these are my tissue culture labs. And we are able to grow, see, look at my lab. Not like now we have standardized 70 different orchids tissue culture process. Out of those, maybe 30 indigenous orchids of Odisha itself. So that for our conservation approach, reintroduction approach, we are providing the seedlings to the forest department. And as you know that the orchids are highly prone to the virus. We have a real-time based detection methods I have already standardized. In 6-7 years before the COVID, I had a real-time machine I standardized thoroughly. And even if I have the technology, even if 20 molecules of virus will be there, if you leave section, that can be detected. Highly sensitive tools. I have not published that paper. We may file a patent for that. Is a TACMAN system. And also, since the certification system requires that all need to be virus free, all need to be genetically identical, I have also highly reliable molecular markers, again for the, only for the Darsonia, or we are developing for the other orchids right now. And some of the diseases also, and we have some entomologist, Mr. Sir, retired sir, is helping us identifying different diseases and pest also. And in consultation with NRC orchid, we have this novel formulation how to deal with those diseases. These are our own photographs, from our own experiences. Thank you all.
Thank you, sir. Thank you very much. Very excellent presentation. In fact, I would appreciate, we have been importing orchids, cut flowers from Thailand and South Asian countries. So it is high time we should have our own technologies, our own varieties, so that we can go for import substitution. So we have all the resources, the favorable climate. Odisha has got a lot of potential. So only thing, we need to convince the farmers, we need to take the technologies to the end users. Thank you, sir. Thank you very much. And I would like to join you to acknowledge the great work done by Dr. Palai at RPRC. So I have seen even before from RPRC, a very good friend of me, very good achievements. The first time tissue culture, whether it is banana, started with banana and went into a number of crops. So thank you very much, sir. Thank you. Thank you.
Thank you very much, sir, once again. Now I would request our chairperson to kindly come up on the stage to felicitate Dr. Nihar Ranjan Nayak. I would request ma'am to kindly join us for the felicitation. Dr. Yes. Let us have a louder round of applause for Dr. Nihar Ranjan Nayak. Thank you very much for doing the honor. Please be seated. Moving on now, please welcome Dr. Pratibha Sahu from ICAR IIWM Bhubaneswar. She will be talking on evaluating aquaponic derived and synthetic nutrient solutions for lettuce cultivation in vertical hydroponics. We welcome you, ma'am.
Good afternoon, one and all present here, respected chairman, co-chairman, rapporteur, all the delegates of this conference, ladies and gentlemen. Myself, Dr. Pratibha Sahu from ICAR Indian Institute of Water Management, Bhubaneswar. As you know, the urbanization is likely to be increased from the present 35% to 64% in 2050, and our population may be 10 billion in 2050. So demand of food is going to be increased by 70%. But see, our per capita land ability is 0.2 hectare, maybe the total land ability, and arable land is even if less, 0.107 hectare, whereas per capita water ability is elevated at 43 meter cube per year. So with this less land, if you want to feed the Indian population in 2050, we need an horizontal expansion of land as big as Brazil, which is not possible. So global land and water crisis is threatening our food production. And if you see the horticulture and aquaculture sector, it is directly involved in the Sustainable Development Goals, SDG 2 and 12. To meet the demand of the daily calorie, that is 1500 calorie, our production system is challenged by increase of climate change, induced crop failure, overall resource problems like poor soil fertility and less chance of natural soil fertility buildup, and poor water management, decline groundwater level. To meet these challenges, the new terms hydroponic, aeroponics, aquaponics, vertical farming, these terms evolved. This is nothing. The space, if you see the space coordinate view in a horizontal farming system, we are utilizing X and Y axis, and when you are going to utilize the Z axis, that is known as vertical farming. Different types of vertical farming, circulating, non-circulating methods, soilless media, also known as aggregate hydroponic system, aeroponics, like this. In India and the world, mainly vertical farming hydroponic is going to be an NFT system, nutrient films technique, where the nutrient-rich water is touching the root system and creating a film. So it is nutrient film technique. But we at ICR, Indian Institute of Water Management, we have designed deep flow technique. Here, the PVC pipe, the diameter will be 10 cm, more than 10 centimeter. We have designed this thing. We have taken one experiment, 3 varieties of lettuce and 2 different systems. One is only hydroponic system and with fertilizer, and another is aquaponic system, 2 varieties of fish, anavas and chana species. You can see in hydroponic system, many hydroponic solutions are available in the market. Hugland solution, Vanderritel solution, many solutions are available, but we at IIWM, we have developed our own fertilizer solution for hydroponic. We have taken that in our experiment, and we found that under aquaponic system, increase of 23% shoot length and 27.5% leaf length, 9% leaf width as compared to hydroponic system, but whereas the root length is much more in hydroponic system. If you see the lettuce yield, the aquaponic green lettuce and the red lettuce recorded highest yield in comparison to hydroponic Roman lettuce. And on water use, aquaponic Roman lettuce required highest volume of water, whereas hydroponic red lettuce used least water. Coming to the water use efficiency and water productivity, water use efficiency showed opposite trend to water consumption, that is hydroponic red lettuce exhibited highest water use efficiency. These are the pictorial of our experiment: hydroponic green lettuce, aquaponic Roman lettuce, aquaponic green lettuce, and tower type red lettuce. Coming to the water quality, if you are introducing the fish in the hydroponic water, then why the aquaponic has more yield? What is how the quality changes during the session? The aquaponic system fish tank showed improved water quality in terms of turbidity and total substrated solid, nitrate, and ammonia, most likely as a result of plant absorption of nutrients. Due to high alkalinity, that is more than 90 ppm, and to 12-hour aeration, there was no discriminate shift in the pH and dissolved oxygen. And coming to the fish parameter, we found under aquaponic system, the growth performance of chana was higher, as evident by performance index and production. When we are considering any production system and utilizing the water, as the fish is the mainly consumption of water, so water productivity, net water productivity, we found with 1 meter cube of water, there is production of 178 rupees. That is economic water productivity. As nowadays, we are not going for more production, quality production and nutritional value. That is nutritional water productivity we calculated for fish. It is 0.276 kg per meter cube. After that, as you know, we have used Internet of Things for automation of that aquaponic system. Previously, in the pre-internet era, there was communication between human to human, then Internet of Content, www, then Internet of Service, Web 2.0, Internet of People, social media, Skype, Facebook, YouTube, Insta, all these things. Now the time is Internet of Things, that is machine to machine. From here we can operate that aquaponic automation model situated at IIWM. We have developed and programming is done for IoT enabled. This is the pH is more than a buffer solution. Automatically it will drop down, and water temperature sensor, water level sensor, and temperature humidity sensor. So the key findings, you can say in aquaponic system, that is stronger vegetative growth, highest yield performance, and water quality enhancement, whereas in hydroponic system, greater root development and precision control. So at last, aquaponics is a possible solution ensuring food security by maximized wastewater and nutrient recycling for simultaneous fish and plant production within the same system. Future implication. This is the work of under NSA project, 2 years experiment, and the future implication, the scale of the pathway for urban and semi-urban farming system, resource efficiency, and policy and extension, governance, education, and for quality assessment, that is in hydroponic we are moving towards the quality. And only 2 publications for last year, and we acknowledge National Agriculture Science Fund and Mission for Integrated Development of Horticulture, and as well as our institute, and 3 design patent and 1 trademark approved at our institute level. We are filing for next week, and 1 radio talk. And this has been, due to this work, our institute has been got the visibility at pan-Indian level and at ICL level. Different ministers and our Deputy Director General Agriculture Extension, NRM. And lastly, this month, DG highlighted this aquaponic system because in India, IRA New Delhi, CFA Mumbai, IIVR, they are doing this hydroponic work, but the combination of fish and crop growth is new to us, and CFA Mumbai, they are culturing the fish, but plant growth is not at par. So under NSA pattern, we 4 institutes are working together, but our work is IoT-enabled aquaponic system that has been highlighted, and also we have developed an aeroponic system of orchid. Thank you. Thank you so much.
Thank you, Dr. Sahu. Very good presentation. In fact, it is, we have to move towards utilization of vertical space. So that is vertical farming. So you have come out with both crops and fish. So very good presentation. So now one clarification, a quick clarification.
Actually, ma'am, I will show you the picture. What we have done in aquaponic system, if you are going to apply the fertilizer, then it will hamper the fish growth also. So we have, in our protocol, we have separate fertilizer tank is there and fish tank is there. And fertilizer is not applied actually for the plant throughout the cropping season. For hydroponic, it is not required that in nutrient-rich water you have to apply throughout the cropping season. Just like in lettuce, for 7 days there will be no fertilizer requirement as such. Then after 11 to 12 days, you have to apply the fertilizer. So when you are going to apply the fertilizer, you have to put in the fertilizer tank itself. Then you have to apply for 2 to 3 hours. After that, in the afternoon, again 2 to 3 hours. Then you have to reflux the system the next day. Again, from the inlet valve will be from the aquaponic system. So there will be no residue of the fertilizer to the aquaponic tank. Aquaponic means utilize. Yes. 2 separate systems. Actually, ma'am, 3 systems. One is pure hydroponic system. Another is pure aquaponic. There will be no use of any external fertilizer. Another is fertilizer plus aquaponic. So how much fertilizer we are going to save if you are using the aquaponic water to the plant? Yes, that nutrient, how much nutrient plant is obtaining from the aquaponic water, that we have calculated. So that we can, 23% less fertilizer we have calculated like this. Or ma'am, this time, this is the fish is biofiltration part when the plant fish is 1 kg, 1100 to 1200 like this is Jana and Anaba species. For lettuce is 45 days to 60 days the crop. During that period, 80 gram or 90 gram fish will be there, and fish will be up to 1 year like this. And with that period, we have to change the crop. After that, you need to biofiltration system, because every crop, while we are changing the crop, we are cleaning
Madam,
the system.
okay,
like
madam,
this.
we
Okay,
can
thank
have,
you.
you can discuss during lunch time. So we are
Thank you. Thank you.
running out of time. We are already late. So we have completed these invited talks. So now we'll start with oral presentations. We have 10 presentations listed here, 10 presentations. So I would request all the speakers to restrict to 5 minutes. 5 minutes. So the introduction part you can minimize to just half a minute, and then actual work what you have done. So that conclusion you can make a presentation. So yeah, you can call upon the first oral presentation.
Thank you very much, Dr. Sahu, for the interactive presentation. Moving on with the oral presentations. Please welcome Rupam Pathori from Dayal Singh College, University of Delhi. Is he there? He is going to talk on ovicidal and repellent activity of Cymbopogon winterinus jewett essential oil against Spodoptera frugivora.
Good morning, everyone. Myself, Rupam Pathori, and today I'm going to present our research work entitled Ovicidal and Repellent Activity of Cymbopogon winterinus essential oil against Spodoptera frugiparda. Are you all familiar with this insect? If not all, our farmers, especially maize-growing farmers, are very familiar with this insect, Spodoptera frugiparda, commonly known as the fall armyworm. It is a lepidopteran insect pest belonging to the Noctuidae family, which has over 350 host plants belonging to 76 different families. The larval stage of this pest is the most damaging stage, as they feed on the leaves and damage the physiological conditions of the health. Now, there are estimates that it can cause an economic loss of 2.4 to 6.2 billion US dollars in absence of control measures. Here in India itself, there are estimates that it can cause an economic loss of up 33% of the maize cultivation. Recently, Food and Agricultural Organization of the United States has issued as a warning as a potential food threat chain to Africa, Asia, and Oceania. Here are some of the news reportings that shows how much damage this insect can cause to the maize-growing regions of India. These are some of the damaging maize leaves. And talking about the geographical distribution, it was first originally a native to the United States, but since 2016 onwards, it started its spread worldwide. Now, what is concerning for us is that since 2018, its spread in India, it gained the status of a severely damaging pest. Now, for long, farmers have relied on the use of synthetic chemical insecticides to manage this pest. But due to overuse and indiscriminate use of synthetic chemical insecticides, this pest has gained resistance against most of the well-known synthetic insecticides like carbamates, organophosphates, pyrethroids, and even Bacillus thuringiensis. Moreover, these synthetic chemical insecticides has harmful effects on environment, human health, as well as non-target organisms. Now, in light of these issues, there is a need to look for an alternative solution to manage this pest. Now, plant essentials are such one alternative which are eco-friendly and generally considered environmentally safe. The test plants in our study, the Cymbopogon winterinus, commonly known as the Java citronella.
Straight away we can go to objective,
yes, sir.
methodology, result, and conclusion.
Yes, sir. Yes.
Introduction is the
8 minutes, I'll finish it, sir. 8 minutes.
5 minutes.
Okay, sir.
Because
Okay.
you have to complete by 1 time.
Okay. Initially, it was 10 minutes, so I prepared accordingly. Sorry, sir. Okay, I'll okay. So for methodology, the essential oil was extracted using hydrosteam distillation method using a Clevenger type apparatus. For this, we took fresh leaves of citronella. We washed it with distilled water to remove any darts or insects attached to it, and then sliced into small pieces and then put in the Clevenger type apparatus as shown in the figure. And two distinct phases were observed after the distillation process. One was the aqueous phase that contained the aromatic water, and the other one was the organic phase that contained the essential oil. The essential oil was separated from the water by separating funnel, and the essential oil extracted was subjected to GCMS analysis. Now, two types of to have a continuous supply of the insect culture in the laboratory, we cultured the culture of Spodoptera frugiparda in the laboratory as shown in the, I'll go to the next slide. Now, two types of bioassays were performed. One was the ovicidal bioassay, and the another one was the orientation bioassay. The ovicidal bioassay was performed against the eggs of Spodoptera frugiparda, which were 24 hours old. 4 concentrations of the citronella essential oil prepared using water and 280, and the control solution contained only water and 280. 100 microliter of the test solutions were applied to batches of 10 eggs kept in a petri dish, and they were observed for 5 days under standard rearing conditions. After that, the eggs that did not hatch even after 5 days were considered dead, and from there, percent ovicidal activity was calculated by the formula T minus C by 100 minus C into 100, where T stands for mortality of eggs in the treatment and C stands for mortality of eggs in the control. Now, for orientation bioassay, it was performed using a glass tunnel olfactometer, which was placed inside a rectangular test arena as shown in the figure. The whole test arena was illuminated uniformly with the help of a LED light that was placed below the test arena. The glass tunnel olfactometer was equally divided into 3 zones, the S, C, and B. S stands for the stimulus, C for central, and B for the blank zones. Now, 4 different concentrations of the citronella essential oil were prepared, and a Wattman filter paper of 3 centimeter diameter was dipped in the respective concentrations and were provided at the stimulus end as a stimulus, and a Wattman filter paper of the same diameter, which was dipped in the control solution, was provided as in the blank. Now, 10 freshly hatched larvae of Spodoptera frugiparda were placed in the middle of the glass tunnel olfactometer, and their movement were observed and recorded for 15 minutes. Now, moving to the results of GCMS analysis indicated that citronella essential oil consists of 3 major components: citronellol, citronellol, and geraniol. Citronellol 26%, citronellol 13%, and geraniol consists of 24%. Now, the results of ovicidal bioassay indicated a concentration-dependent percent ovicidal activity of citronella essential oil against the eggs of Spodoptera frugiparda, as it is clear from the table that as the concentrations of citronella essential oil increasing, the percent ovicidal activity also increased and reached a maximum of 96% at 2.5 mg per ml. Further, probit analysis was done to calculate the 50% lethal concentration of citronella essential oil against the eggs of Spodoptera frugiparda, which came to be around 1.57 mg per ml. The results of orientation bioassay also indicated a concentration-dependent repellent activity of citronella essential oil. As we can see from the graph, that as the concentration of citronella essential oil increasing, which was provided as a stimulus at the stimulus end, the more of the larvae were moving away from the stimulus towards the blank end, suggesting repellent activity. Now, further percent orientation preference was also calculated, which was highest 77% at 20 mg per ml. The negative sign here indicates the repulsion of the larva by the stimulus. So to conclude, we can say that Symbopogon winterianus, that is the citronella essential oil, can be used as a potential agent for the management of Spodoptera frugiparda. Our future perspective includes the development of nanoemulsified formulation of citronella essential oil to overcome the issue of high volatility and easy degradation of essential oils, and will further do the characterization, bioefficacy, and toxicity studies of the developed formulations under laboratory as well as field conditions, for which we have signed an MOU with Tamil Nadu Agricultural University. We are thankful to CSR for providing us a grant under the Aspire scheme.
Thank you.
These are research.
Mr. Rupam Patauri. Very good findings. It will.
These are very preliminary studies only with the oil. So for eggs, we are 2.5 mg per ml, sir.
2.5 mg, they got 96%, but it has to be validated.
It's not to 100% eradicate the Spodoptera. We just need to keep it below economic injury level. So that is the ecological approach.
Right. It will go a long way. Thank you very much.
Thank you, sir.
You can come down. So I would like to call upon Dr. Omar Fayaz Khan from SK Sher Kashmir University of Agricultural Science and Technology, Kashmir. Is there? Okay. Next,
Yes, yes,
we have. Is there?
we'll be presenting online.
Oh, you are presenting online. Okay.
Yeah, yeah, sir. So let me share the
Yeah, please note the
screen.
time is 5 minutes.
Okay, okay,
You
sir.
can just emphasize your objective and the conclusions, the results.
Sure. So I'm presenting on behalf of my whole team, Dr. Umar Fayaz Khan, who is assistant professor and PI of our project. And this is Muzain Wani and my fellow Iram Gulzar. Now, the title of our study is Indigenous Knowledge-Based Livelihood Mapping for Economic Empowerment of Tribal Communities in Fragile Mountain Regions of Kashmir. So, introduction will be very short. As we all know, that tribal communities in Himalayan regions of J&K, they have rich livelihood skills which are rooted in deep indigenous knowledge systems. You know, traditionally they rear livestock, they go for pastoralism, they do their, they go for agriculture as subsistence based, and they have a lot of ethnobotanical knowledge. So, tribals constitute 12% of the total population of Kashmir. So, but in recent decades, it is being seen that pasture scarcity and climate change are the major challenges that they are facing. There are weak institutional linkages. There is limited livelihood mapping and employment opportunities, and there are a lot of social political conflicts also going on in the area. So, despite having strong indigenous knowledge systems, there is still a lack of formal livelihood planning. And us, in our study, we have tried to map the livelihood systems of these tribal people. So, the main key employment oriented domains that we observed were ecotourism, medicinal and aromatic plants, dairy based activities, wage labor, and handicrafts. But in this study, we have only focused on three main occupations, that is tourism, MAPs, and dairy based activities. We have two objectives in the study. The first being to assess the pattern of livelihood diversification among tribal community of Gandabal district. Second is to identify and rank the major constraints affecting livelihood activities of the tribal community. Coming to methodology, the study area was Gandabal, and 20% of the total population in Gandabal is Gujar and Bakarwal, which are scheduled tribes. The district is, surrounded by Greater Himalayas and Pir Panjal range, and it has its boundaries with Srinagar, Bandipur, Anantnag, and Kargil. The whole region is environmentally very fragile and economically vulnerable, and there is a very limited scope for industrial growth. So we studied 10 villages. This is the list of villages, and this is the number of households they constitute. Data sampling data was simply collected using multi-stage sampling design. And we selected Gandharbal purposely because there was a prevalence of these tribes in the district. We have selected 10 villages and 40 respondents per village. So total respondents we have 400. Then these are some pictures of our study areas. The middle one showing their culture, how they prepare feasts and all that. And the beautiful landscapes also you can see on the screen. Now coming to framework, we have employed Simpson's Livelihood Diversification Index to find the degree of diversifications they are opting for in their day-to-day occupations. And secondly, we have Garrett's ranking technique where
Please
we
come
have.
to your results, madam. Please come to your results.
Okay. So this is my results section. But before actually discussing the results, I want to tell you that some of the study areas were there are already some famous tourist places. So all the people living there, they thrive on tourism only. They provide services like homestays, guides, handicraft sales, and all that. Dairy activities almost like most of the people, they rear their livestock and they sell their produce in the market, and they also go for value addition. Then the last one being medicinal and aromatic plants. It's very limited because there are restrictions, as we know that Forest Rights Act 2006 uh, restricts most of them to collect, costly medicinal and aromatic plants. Now, a result of my first objective, we could see this is the list of villages, and this is my SLDI, Simpson's Livelihood Diversification Index. It shows that in three villages, there is a very low diversification, and that means they have a very strong dependence on just a narrow set of livelihood activities. They are very vulnerable to shocks, to market fluctuations, and livelihood disruptions. And there is, their income stability is very low, and they are seasonally unemployed, I can say that. So these numbers like 0.06, 0.1, these are very small numbers and these indicate a very urgent need for some interventions. Then moderate diversification. Six villages were those villages there was moderate diversification that somehow helps them to manage risk because if it provides a better stability. So it also reduces dependence on single occupation. So there is a scope of further diversification still because these numbers is also very low. Only one village among 10 villages was the one where there was high diversification, which means that they have very less dependence on single activity and they have a stronger skill base and economic linkages. Coming to second objective, these are the problems that we managed to collect to ask the respondents, and these are the problems that they were facing. And then using the direct ranking technique, we ranked these problems according to their severity. This is the table, and most severe problems we could find were lack of training and skill development and lack of promotion and marketing support. That means there is a need for intervention at a higher level. Second one was moderate constraints, lack of government and NGO support. There were poor facilities and infrastructure, and animal disease and fodder scarcity. Obviously, it obstructs their milk production and affecting their livelihoods. And least severe here was seasonal nature of livelihood activities and poor road connectivity. Roads are very good to these remote areas, but then other facilities are not there. We want to suggest some policy implications like first of all, because our project is focused on the livelihood security of the tribals, so we are suggesting that there should be capacity building programs for those people and they should be relevant to their local livelihood systems. Like we have to preserve their culture also and at the same time we have to provide them with better livelihood options. Secondly, there should be improved access to productive infrastructure and market linkages. There is a strong need for collectivization, like farmer producer organizations, SHGs, and cooperatives, so that market channels will be eased for them for their local products. Then coming to MEP part, which is very still in a very nascent stage, if we promote on-farm cultivation of maps, we can provide a really good option for them to earn their money because they are deeply dependent on forest products, be it timber products or non-timber products. Then land and forest rights should be recognized for significant economic payoffs. Then there should be community-based milk chilling units, cold storage facilities, small-scale processing units, because those people they do not have the processing facilities that results in the and also the milk, which is very highly perishable. They have to dispose it off, even at low prices, and they get low prices because they don't have the cold storage facilities.
Madam,
Lastly,
thank
coming to
you.
conclude,
Conclude it, madam. Conclude it.
yes, this is the conclusion. So, our study highlights the persistent poverty and income instability among tribal households, and that's why we need to do some major interventions. We need to avoid, if there is a uh, limited access to productive infrastructure, market linkages, and storage facility, we need to frame such schemes that can uplift these people. So there is a need for shift from short-term scheme-driven approaches to integrated development strategies that combine all of them together and plus preserving their indigenous knowledge also. So future research should focus on longitudinal and impact-based analysis to better capture dynamic welfare effects and inform evidence-based tribal policy design.
Thank
Thank
you.
you.
Thank you, madam. Can you tell your name again?
Yeah, this is Muzain Ghani, and my team is
Zain Ghani.
Dr. Umar Fayaz Khan and Iram Gulzar. We are three people, and we as a
Fine,
team are
fine.
representing this. Yeah,
Fine. Thank you. Thank you. Very
thank you.
informative at grassroots level uh, interventions. Thank you very much.
Thank
We'll
you.
move on to next speaker, Mr. Ramana Partha Madhaviji Bai. Are you there? Okay. Yeah, please restrict to 5 minutes. Already lunch is ready. We have to prepare for lunch. So no introduction, just half a minute. Directly the objective and your research findings.
Hello, hello, respected judges, my dear colleagues. My name is Ramana Prath from Department of Genetics Plant Breeding, Swartz, Prayagraj. Here I am presenting my part of the research expression of virus tolerance in a hybrid and a segregation generation in a chili. So, total area of chili crop is a 1.5 million hectare. Among them, 30 to 40% chili area are affected by the viral disease. And these are the red mark on the map. It's your hotspot of the hotspot of the hotspot of the disease. Okay. Among chili loss is yield 80 to 100% due to the severe infection cause of the due to the severe infection. To reduce its yield, farmer overuse the chemicals due to the overuse of chemicals. Now we are facing the human health, environmental effect, soil health, and we are losing the beneficial insect. These are the life cycle of the life cycle of the virus in the plant. A breeding strategy for development of virus resistant in chili. First we are evaluate genotypes. On the basis of PDI. We found resistant and susceptible plants. We are cross them and develop the F1. In F1, we evaluate as a fruit to raw method. After that, we from the F1 we next go to the F2. Here is my result. In my genotype evaluation, we did the cluster analysis. In a cluster analysis, we found two clusters. A cluster analysis group genotype into two distinct clusters. One is a resistant, and another is a susceptible. Resistant genotype show the low PDI in a thicker leaf structure. Susceptible genotype exhibited high PDI in a thinner leaf. Genetic divergence among the cluster indicates scope of effective parent selection. Based on the PDI and clustering, divergent parent was selected to the hybridization. This is my F1 performance for the viral disease and leaf trait association. PDI increases from the 60 to 120 days in all groups. Resistant parent consistently showed lowest PDI. Susceptible parent recorded the highest PDI through the crop growth period. F1 hybrid exhibited the intermediate PDI response, indicate the partial dominance of the virus resistance. Low PDI in the F1 compared to the susceptible parent confirm the transfer of resistance. The cluster analysis of F1 hybrid. And the cluster analysis divide the F1 in the three distinct clusters. First cluster is a high PDI, second is a moderate, and third is a low PDI. Means third cluster has the resistant F1. The segregation pattern of disease response in F2 population. F2 population show the wide segregation for the disease response. Resistant plant. There is example of segregation in image. In a one line, we found two plant. One is susceptible and other is a resistant. So we select the resistant plant for the next you'll F3 generation. Conclusion. Significant variation for the viral disease was observed among the genotype and segregating generation. F1 hybrid exhibited the intermediate disease response, indicating partial dominance of the resistance. Wide segregation in a F2 population enabled the effective plant-based selection for the resistant recombinants. Leaf thickness show a negative association with a PDI, supporting its role as a useful morphological indicator of the resistance. The study demonstrated the potential for the developing virus-resistant chili line through the integrated phenotypic and trait-weight selection.
Thank you.
Sir, for the chili leaf curl virus. Yes, but although we are not identifying because for that we have to go for the molecular. So in next 2 or 3 months we will go for the molecular. Hmm. Sir, on the phenotypic basis, we observe the chili leaf curl virus, sir, on the phenotypic basis.
Okay, thank you, thank you. It's chili leaf curl virus. So, next speaker, Sridevi Meena.
Yes, I'll be presenting online.
Sridevi Meena. Online. Sridevi, it's time allocated is 5 minutes.
Yes, sir.
Please stress upon your objectives and the findings.
Yes, sir.
Introduction need not be emphasized, need not be elaborated.
Okay.
Okay, 5 minutes.
Yes, sir. Good afternoon, all. So I'll be presenting on the estimation of genetic variability and screening of micronutrients in traditional rice land races. As we know that rice is a major staple food, providing a large share of calories in India. But the polished rice which we usually consume is poor in iron and zinc, which leads to hidden hunger, leading to health problems like anemia, low immunity, etc. So I focused on categorizing land races for both yield traits and iron and zinc content. So my main focus is to measure the genetic variability for yield and yield related traits, to quantify iron and zinc content in brown rice, to identify land races combining good yield with high iron and zinc content for the use in breeding and biofortification programs. So I started by evaluating 25 land races plus one check variety using a randomized block design with 3 replications under recommended NPK. For these 25 land races, I recorded 13 quantitative traits, which included the following. Together, these gave a complete yield profile for each land races. Furthermore, the brown rice samples of each genotype were analyzed at IRI for iron and zinc content using X-ray fluorescence, which is a rapid non-destructive method for estimating elemental concentrations to give iron and zinc values in ppm for all land races. Furthermore, the ANOVA showed highly significant differences among genotypes for all 13 traits, confirming wide genetic variability, and high genotypic and phenotypic coefficient of variations were observed for biological yield, harvest index, and grain yield per hill, indicating large scope for selection. Out of all of these, Kalamali Fool recorded the highest grain yield per plant. Then the iron content among land races ranged from 10 to 20 ppm. Sathi and Kalamali Fool had the highest iron content, while the zinc content ranged from 15 to 33 ppm, with zinc rice MS as the highest with 33 ppm. The iron and zinc were moderately positively correlated, so lines high in iron were also found to have high zinc as well. So, as to summarize, traditional rice land races constitute a genetic goldmine for crop improvement. Their innate genetic diversity offers wide range for characteristics like disease resistance, climate adaptation, and as this study found, distinct nutritional profiles. The difficulties of global malnutrition can be addressed by developing superior crop types with greater nutritional value. Given the widespread micronutrient deficits seen in people using rice as a main source of nutrition, the existence of rice land races with high concentration of iron and zinc is particularly encouraging. Thank you.
Thank you. Very good presentation.
Thank you, sir.
How many season data? Is it 1 season or 2 season?
1 season.
You have, at least if you take a 2 or 3 season data, the data is more reliable.
Okay, sir.
Thank you.
Yes.
So you next we call upon next oral presentation, New Muskan Yadav. He is here. Okay, next is Sobiga Rangan.
Good afternoon, everyone. Myself, Saubiga Rangraj, a senior MSc student in vegetable science. Today, I would like to present a part of my research work, which is entitled as Identification of SSR Marker Linked to Fruit Flavor QTL, FLD 1.4, Heading for Marker Assisted Selection in Muskmelon. Coming to the basic introduction of my crop. It's not my presentation. But this is not mine. You change that. Aggravation, Sobika Rangaraj. Yeah. Coming to basic introduction of my crop, muskmelon is an economically important crop with high market value, and we widely enjoyed as a dessert fruit because of its attractive and unique musky aromatic flavor. Owing to its cross-pollinated nature, muskmelon exhibits a wide range of genetic diversity across both plant and fruit traits. So this genetic diversity offers a significant opportunity in breeding program aimed at improving fruit quality, nutritional value, adaptability, and yield. This figure illustrates the IHR developed advanced lines and cultivars, which show a clear difference in flesh color, rain color, netting pattern, and netting density. Apart from yield improvement, my research study focused on market demand and consumer acceptance by improving the fruit quality traits. Breeding cultivars with a high quality traits is a major breeding challenge, especially in fruit flavor, because fruit flavor is a complex physiological process and is highly influenced by genotype, environment, and ripening related metabolic changes. Interestingly, fruit flavor is perceived through combined perception of taste and aroma. Aroma is a major part of the fruit flavor, and it develops during ripening and is closely associated with a high respiration rate and ethylene production. Mainly fruit flavor enhancement in muskmelon is negatively associated with the soft flesh and reduced storage life. As we can see, which is a major breeding problem in handling, storage, and long distance transportation, which can clearly seen in the climatic fruit of Arcasiri. So to improve the post-harvest life, climatic muskmelon are often harvested early maturity stages when the fruits are firm. So this results in a inferior sensory quality in terms of fruit flavor. So to address this challenge, the breeding line, advanced breeding line IHR OPM1, which is characterized by high fruit firmness along with the advanced higher shelf life. So we are planning to utilize this. We plan to utilize this in our muskmelon breeding program as a part of my research. We introgressed both the fruit flavor and fruit firmness associated traits through intraspecific hybridization. Therefore, in upcoming generation we could able to advance these lines along with these desired traits. So, as I said, fruit flavor is highly influenced by environmental factors. So, making molecular marker an efficient tool to isolate and track the flavor associated genomic regions which is independent of the environmental factors. Coming to aim of the objective of my study, we screen different public domain markers in my intraspecific cross, and we identified the polymorphic SSR markers related to the fruit flavor. These polymorphic marker were validated across the F2 population for the fruit flavor trait. So we were employing marker linked to the fruit flavor among the intraspecific cross, and to facilitate the targeted fruit flavor improvement through marker associated selection. Coming to materials and methods, we developed an F2 population from a contrasting traits. From an intraspecific cross consists of contrasting traits of muskmelon and oriental pickling melon. In this cross, we can clearly see the contrasting traits of Arcasiri and OPM1. Among these traits, we particularly focused on fruit flavor from Arcasiri and high fruit firmness from, well, in case of OPM1, we focused high fruit firmness. So here we, by introgressing both the traits, so we could able to advance these lanes in future generations. So this can be used for marker associated selections. We used around 20 public domain markers associated with the different fruit traits of muskmelon. Of this, we screened. Of this, we screened these markers in my in my populations containing Arcasiri, OPM1, and hybrid. Coming to results, these co-segregating markers exhibited a clear polymorphism in Arcasiri and OPM1.
Okay, you noted. Next slide.
No, wait.
No, time is up. Already 4 minutes over. I'm not in control.
Okay. This parental polymorphism will be were further validated in the F2 population. So the fruit flavor linked SSR marker was identified in the F2 individual associated with a high flavor fruit trait containing a distinct band size of 120 base pairs in Arcasiri, 110 base pairs in OPM1, and in the F2 individual showing high flavor for the high fruit flavor associated trait. So here I would like to conclude that the co-segregating SSR marker showed a clear polymorphism in the F2 segregating population, which confirm its association with the fruit flavor QTL FLV 1.4 and validates the potential use of marker assisted selection. So in addition to this, I would like to say that we detected fruit firmness related marker in our population, but not yet validated in the F2 population. We are and we aim to enhance both the traits in upcoming generation into a single genetic background. Thank you.
Okay, very good presentation.
Yes, sir.
Population size also good, 400
Yes,
to
sir.
population. So you have to calculate the R square value.
Okay, sir.
Huh? You have to any other questions? So then we can have next presentation by Kumar Siddharth. Kumar Siddharth is there. Then next presenter is Tharun.
Plutella xylostella. Escalating insect pressure on crops has resulted in heavy reliance on chemical insecticides, which resulted in resistance development, environmental hazards, and food safety concerns. However, plant-based biopesticides provide an alternative, but these are limited in their use due to their high volatility and easy degradation. But these challenges can be overcome by nanomulsion. Nanomulsification of essential oil provides stability, bioavailability, and persistence, bridging the gap between the laboratory efficacy and field level conditions. Cruciferous crops such as cauliflower, cabbage, broccoli, mustard are among the most important vegetable crops worldwide. In India, they are not only nutritional staples, but also among the major cash crops worldwide. These crops face a persistent and devastating enemy, that is the diamondback moth, Plutella xylostella. This pest is widely distributed in 128 countries, caused loss of around $4 to $5 billion worldwide. In India, it caused loss of 16 million US dollar. What makes Plutella particularly challenging is not only its larval feeding damage, but its remarkable reproductive capacity. A single female can lay hundreds of eggs, setting the stage for rapid population explosion. To cope with this, farmers frequently rely on repeated insecticide applications. This resulted in enhancement of production costs, resistance development, as I said. So, this DBM is ranked second for highest number of insecticide reported resistance. It has ranked, it was the first insect pest to develop resistance to DDT, and it has developed around resistance for around 97 number of insecticides due to its high reproductive potential and ability to resist to wide range of toxins. So as I
Madam, we can
told
move
about
on to
this,
the objective.
moving to workflow, C. vintainus essential oil or CW essential oil was extracted out by hydrosteam distillation method, and then nanomulsion was prepared by spontaneous emulsification method that I'll discuss next, and then characterized by DLS and TEM, and bioassays were conducted. Here quickly, to prepare nanomulsion, a mixture of oil and twin 80 was stirred on magnetic stir for 30 minutes. After that, double distilled water was added to it. Subsequent stirring for 2 hours resulted in desired nanomulsion. This is its life cycle. Then oviposition bioassay was conducted. Quickly moving to the result, GCMS analysis revealed the presence of 13 compounds, major being citronellal, and geraniol. These oxygenated monoterpenes are known to influence insect behavior. So here it is important as DLS measurement revealed that average hydrodynamic diameter size was varied from 247 to 270, and a low PDI value was obtained. So this shows that our nanomulsion has a narrow size distribution with no major change in droplet size over days. And then to further validate, we did TEM, which revealed homogeneous spherical droplets with average size of 124.89 nanometer diameter. Together, DLS and TEM confirm that our nanomulsion is both physically stable and structurally uniform, that is essential for reliable bioassay performance. Then two bioassays were conducted, no choice and two choice. In no choice bioassay, all the concentrations of both oil and nanomulsion showed significantly reduced egg laying as compared to control. You can see the dose dependent effect, but that is very clear. However, across all the concentration, nanomulsion was significantly higher in activity as compared to essential oil, as it increases surface area, bioavailability, and persistence of bioactive compounds. Similarly, in two-choice bioassay, oviposition deterrent index values showed significantly higher in both oil and nanomulsion. But here also nanomulsion was, across all the concentration, nanomulsion showed higher activity as compared to oil. So this, overall, this says that our nanomulsion is a CW-based nanomulsion, strong oviposition deterrent to manage P. xylostella-based populations. This shows that we are not killing the insect, we are actually changing its decision. We are further conducting shelf life, formulation stability, field trials also, and broad spectrum testing against lepidopteran pests. So to conclude that this work aims to contribute towards sustainable pest management solutions that protected both farmers' livelihood and consumer plates, that ensures that cabbage in our curry or filling in our spring roll comes with less chemical burden, and more ecological balance. So by changing the insect choice, we change the outcome for the crop, the farmer, and the livelihood. So thank you. These are
Very good
acknowledgements.
presentation.
Thank you, sir.
This lab work you have been carried out the OV position. Say how many times you have repeated?
Sir, actually this is of about 2 years data, but I am showing a little bit as it is my present, I am publishing this work.
But in field condition it should be validated.
Yes, sir, I have to validate in field conditions.
Thank you.
Thank you, sir.
The next presentation is Sandeep Nalla.
Good afternoon to all of the dignitaries present over here. So myself Sandeep, I am a PhD scholar in genetics and plant breeding from Shuarts, Prayagraj. So this is not actually research work. This is like a a suggestion to throwing light into some new concept. So I'll be talking about stomatal response under heat and drought stress. So basically, while talking about
You can restrict to 5 minutes.
Yes, sir.
You can just
I'll
major
just give
points,
I'll just give
points,
a
what you
outline.
would like
That's
to
it.
do.
Okay. So basically, when talking about climate change, you're talking about singular stresses. Like if you're talking about heat, you're always talking about heat. If drought, always drought. But we do not look about the combined stresses. So now we are focusing on heat and drought as coupled stresses because heat and drought are coming together. So in the same way, the plants tend to relieve their heat by opening their stomata and relieve the heat outside. And during drought, the plants will try to close the pores so that they need to conserve the water. So when heat and drought are coming together, then the plant goes into a dilemma whether to open the stomata or not to open the stomata. So basically, that is the core problem. So under combined heat and drought stress, stomata face a fundamental dilemma requiring active integration of opposing signals to maintain physiological homeostasis. So we all know about heat stress and what happens during heat stress, so I'll not throw so much of light on that. So basically what is happening is during heat stress, the stomata need to open, and during drought stress, the stomata needs to close. So when the drought and heat are combining together, the plant goes into a dilemma where it is called as where you can see this, that is called as oscillation of stomata. For 15 to 60 minutes, the stomata will start to oscillate, open and close the pores. So that is what happening during, combined stress. So this is not present in all types of plants. Some plants which have adopted this mechanism of, quoted as, resistant plants towards heat and drought, but not all the plants have this system. So the stomata plays a major role in dissipation of heat, heat stress, because they exchange the gases outside. So when the core temperature increases more than 35 degrees centigrade, the stomata needs to open so as to dissipate the heat outside. But when drought is combined with that, so the plant cannot open its stomata, so that it needs to conserve its water. So, and as you can see here, there are two responses. There were, I'll show it here. So there is a signal conflict, that is when TOT3 is acting, that is it is restricting the opening of stomata so that it needs to conserve the water. And when OST1, the open stomata 1 is switch is opening, then it is opening the stomata so that it will allow heat dissipation. So when both of the stresses, when they combine, we might think that both the stresses will come together and will cause a major problem. But the plant does not take it that way. You can see in the heat stress, the transpiration rate is increased. In drought stress, the transpiration is decreased. But when both are there, the plant does not accumulate both the stresses, but it will try to approach a new approach, that is a median approach. So the plants showing this response are quoted to be resistant to heat and drought. So what we can see, so this is the, the activation of heat and drought. The oscillation of stomata, you can see, as you can see it here for 15 to 60 minutes. So guard cells serve as the mechanical computers that help in opening or closing of the stomata, in which you can see during one type of stress it is open, then it is closed, and when both are converging, then it is oscillating. Okay. Then the basic conclusion here is that we are looking about, nowadays ACRIP trials are going on heat and drought combined stresses and all these things like timely, late zone, irrigated and non-irrigated things. We are looking about molecular, morphological insights, but we need to look into physiological insights that also, by that I mean stomatal stomatal studies should be done. So that is the basic conclusion of this. It is like a suggestion.
Thank you. Thank you, Mr. Sandeep. Yeah, very good collation of information. It's a long way to go. We need research on this prior.
Thank you, sir.
Thank you. We'll call upon the next speaker, Dr. Debashish. Dr. Debashish Mandal from Mizoram University, Aizawl. Are you there?
Yeah, I am there.
You are online.
Yeah, I'm online.
Okay. Okay. So time given is 5 minutes. Kindly try to finish it in 5 minutes. You can start. You can share your presentation.
Yeah, I'm just trying to share.
Are you there online, Dr. Debashish?
Yeah, I'm there online, but I'm there online, but it's taking time to cast it. I don't know. Just a minute. Just a minute. Can you see it?
Yes, it's visible. Slides are visible, you can proceed.
Yeah. Okay, so this is post-harvest use of sodium nitroprusside and silac coating, which is maintain the food quality and shelf life of sapota in ambient condition. It will be a brief presentation. So basically, sapota is a sugar-rich fruit and it is having very short shelf life. And because of that reason, when we used to store in ambient condition, as because it is mostly traded in that condition, so the shelf life is very less, around 7 to 8 days, and it used to go to spoilage. So because of that reason, we were trying with two important agents. One is sodium nitroprusside, which is a nitric oxide toner, which is having proven result into different other foods in case of modulating the ethylene biosynthetic pathway. And the other one is shellac, which is a edible natural resin to coat it with to restrict the moisture loss and manipulate the gaseous exchange. Now, in the materials method, actually we have used two different doses of SNP, and that is 0.02 millimole, and another one is 0.05 millimole. And in shellac coating, we have used 2%, one is 2%, and another one is 5%. And the other treatments are the combination of both these with 0.02 with 2% shellac and 0.05 millimole of SNP with 2 and 5% of shellac along with control. Now, firstly, the lot of the fruits we have moved the UVC for around 60 seconds, and then we have given the treatment and stored it in 20 to 25 degrees centigrade, 65 to 85 percentage of relative humidity, and the observations were recorded on weight loss, food length, diameter loss, means shrinkage, and then food texture with texture analyzer. and then pulp color with chromometer of polycomalometer, and then TSS, acidity, total sugar, reducing sugar, ascorbic acid, phenolics. And these we have done in 3 days interval, and then antioxidant and decay percentage and overall the shelf life. Now, coming to the results, so in the result in physiological weight loss, we have seen that the T6, which is essentially 0.02 milligram with select coating 5%, that has given, I am focusing on the K12 result. It is 11.59% of weight loss, where it is in control, it is 23.6%. Now, coming to the length and diameter decrease, it is in case of the two treatments in T8 and T6, it was quite low, around 7.98 or and 8.54% of length decrease, and in diameter decrease it is 6.12 and 7.56% after 12 days of storage in comparison to the control, where it is 12.08 and 9.94% of length and diameter decrease. Now, coming to the texture, as because the fruit got moisture loss during the storage and the tissue disintegrated, because of that reason, the texture or the firmness of the fruit has been reduced. We have measured with fruit digital handheld penetrometer, and we found that after 12 days of storage, T6, it is still having 29.39 neutron per centimeter square of strength in the skin tensile strength, where it is 4.87 in case of control. The pulp color we have measured with a chromometer, and then we have used mixed color sensor software to correlate into the to convert it into the color docker, and you can find that in case of T6 and T8, the color are still greenish, where in the other cases it has already taken the overripe or the ripened color of the pulp. Now, coming to the TSS, it is 18.86. The thing what happened that with time the TSS has got increased because it is a climatic fruit, but later on because of the higher respiration and the senescence, then after reaching a peak, it has gone down. So in case of control, we have found that it has reached this peak and it reached up to 19.56 degrees, but later on it reduced to 14.85 at 12 days. Whereas in case of T6, it is consistently increased, and but the increase is quite slow, and it has reached around 18.86 degrees after 12 days of storage. Whereas the retention of titratable acidity was also higher, but in case of control, the acidity has been oxidized, and because of that reason, it is gone down. Or for the respiration, the acid has been utilized. Because of that reason, the acidity content of the food has been reduced, and because of that reason, you can get a very high sugar acid ratio in case of the control, where is at around 247.5 after 2 days, but it is quite well around 110.94, because here the acidity was also considerably high, having a very good sugar acid ratio. Now, coming to the total sugar content, as the sugar is a very important contributing factor for the for TSS content, we found that after 12 days, in case of T6, it is around 16.87 percentage of total sugar, and in case of T8, it is around 15.98. But whereas in case of the T9, which is controlled, around 12.87% only. Now, in case of ascorbic acid and total phenolics, in ascorbic acid also we have seen that from 3 days to 2 days, consistently it reduced almost in all the treatments, and phenolics also it has been reduced, mostly because of the oxidation and also because of the respiration and exposure to the normal light and temperature. Now, after 12 days, it has found that the retention of ascorbic acid was quite higher in case of T6, around 10.32, comparatively higher than that of the control, where it is only 4.32 milligram per 100 gram. And total phenolic also, it is 0.35 in comparison to 0.12 milligram cateching equivalent per gram of food weight. Now, in antioxidant activity, as because the higher retention of ascorbic acid and phenolics, so T6 has given higher percentage inhibition of DPPH, around 76.97, in comparison to 16.52% of control. Now, finally, in fruit decay and shelf life, we have found in P6 and P8, the fruit decay percentage is quite low, around 13.33 to 20% fruit decay, where it is more than 50% fruit decay in case of P9. And consequently, based on all these parameters, we have found that the shelf life in case of P6 it is 13.73, whereas in T9 control it is 8.87. So merely around 5 days it has enhanced the shelf life when we have specially used this sodium nitroprusside along with the shellac coating. Now you can see it is the appearance of the T6 where up to day 9 after storage also it is having quite intense green inside, not properly repaired. And in case of 12 days, you can get that it has ripened. Whereas you can see this picture in case of control after 6 days is quite optimum in edible conditions because we have taken mature food right, mature your sapota and it has ripened during the storage. So in after 9 days, you can see that it has already started shrinkage and over-ripening of the pulp in 12 days. So from this, we can conclude that post-harvest combined use of SNP 0.02 millimole along with shellac coating 5% can be a potential approach for shelf-life extension of sapota at ambient conditions. Thank you.
Thank you, Dr. Debashish. Thank you. Very good information for extending the post-harvest life of sapota. So now we have come to the close of this session. Around 6 invited talks and 10 oral presentations have been completed. So very good session. I would like to thank my co-chairs and rapporteurs, all the delegates. Thank you very much. We close this session, but we have a small announcement. And I would like to request Dr. Govind Acharya. Dr. Acharya is with some of the flower growers, successful flower growers in Odisha. So they are here. They would like to share their experience of growing flower crops. So Dr. Acharya, over to you.
Thank you, sir, Dr. Nabin sir and Dr. S.K. Pale sir for chairing and co-chairing this session effectively, sir. So on the behalf of all the organizers, I thank you profusely for your time and participation, sir. सर आप लोग को पता होगा कि उड़ीसा में अभी फ्लोरिकल्चर का बहुत इम्पोर्टेंस रहा है और बहुत फार्मर फ्लोरिकल्चर करके बहुत कमर्शियल एवेन्यू कर चुके हैं. जैसे आपको पता होगा गंजा में कई दिन पहले हमारे अर्क प्रज्वल करके हमारे को फार्मर बहुत बेनिफिट हुआ था. ऐसे हमारे साथ 2-3 कमर्शियल फ्लोरिकल्चर ग्रोअर्स है ढेंकानाल डिस्ट्रिक्ट के, हम उनको इन्वाइट किए जो अपनी कमर्शियल फ्लोरिकल्चर से उनका सोशियो इकोनॉमिक स्टेटस और उनका सेल्फ सस्टेनेबिलिटी हो पाता है. तो हमारा अभी जो एक दिन का प्रोग्राम था फ्लोरिकल्चर स्टेक होल्डर मीट फॉर दी ओडिशा, इस सिलसिले में हम उन दोनों फार्मर को इन्वाइट करेंगे. वो उनका वीडियो है जो फर्स्ट है हमारे साथ है मिसेस सुभाषिनी साहू जो ढेंकानाल के है. वो मेरीगोल्ड करके आपका जो सेल्फ सफिशेंसी कर चुके हैं. तो इसमें हमारा जो केपीके है डीन एक्सटेंशन के अंदर है डॉक्टर दिव्य सुंदरकर, और उनको टेक्निकल गाइडेंस दिए हैं इसको सक्सेस करने के लिए. मैं अभी रिक्वेस्ट करता हूँ हमारे जो सुहासिनी साहू से आसिकी टिके आम सहित तांकर जो एक्सपीरियंस फुलर चाष कर कौन तक लाभ कौन से विषय टिके एक्सपीरियंस करेंगे. ता पूर्व मु रिक्वेस्ट करी रिक्वेस्ट जो उत्तर दे टिके स्वागत करेंगे.
नमस्कार मो सुभ्रासिनी साहू ढेंकानाल मठ तेंतुलिया अराजुआ ग्राम आमर फूल चाष तो आप देखिपुं आम गाँ को आमर कृषि विज्ञान केन्द्र जो केबिके आडप्टेड करी अराजुआ ग्राम को तेणु आम अराजुआ ग्राम फूल चाष बहुत भल आकार आम करूँ आमको जो आमर दिव्य सुंदर कर सार जो कही सजेसन देते कि कौ चारा ये करने आमर आर्का अभि आउ आर्का भानु ये दुईटा भेराइटी आम प्रथमे लगेलु जितेबाला ये कलु चारा तो बहुत भल आमको निमाटोड फ्री चारा मिलता से फास्ट ये टे नर्भस थिलु केमिति कौन हम किंतु बहुत भल परिमाण में आमको फूल आम उत्पादन करूँ जेबे आमर जो हेलो आमर जो आर्का अभि आर्का भानु आर्का अभि हूँ आमर ऑरेंज कलर मैरीगोल्ड सेटा आमर मीडियम साइज आउ पार्वण ऋतु रे पार्वण ये आमर सेटा माଳ करिबा पई हो बा सेमती खोला हो बिक्री करिबा पई हमको बहुत सुविधा हुए आउ आर्का भानु जोड़ा सेटा आमर येलो कलर मैरीगोल्ड सेटा आमर सेटा टिके बड़ साइज आसीबो सेटा होउछ आमर सी भी टिके बड़ साइज आसीबो तेणु सेटा भी माळ करिबा पई बहुत भल ये हुए बिक्री पई सेटा पूजा समय रे बहुत भल जेबे आमर दिव्य सुंदर कर सारा आस्तिले आम मानकु बुझेइथिले केमिति प्रॉपर टाइम रे आमे केमिति सठिक चारा पाई परिबा आ सठिक चारा प्रॉपर टाइम रे केमिति लगेई परिबा आउ माने केमतिका ताकू आमे सार प्रयोग करि परिबा आउ हार्मोन ठीक टाइम रे देई परिबा आउ एनपीके ठीक टाइम रे देई परिबा सेही विषय रे हमकु सब बुझाइतिले प्रथम वर्ष जहाँ जमती थिला ता पर वर्षडू आमे सफलतार शीर्ष रे बढ़ी चलीछु सफलता ही सफलता मिली किंतु लॉस हबार कोनोसी चांस नहीं आमे जेबे गेंडु फूल ये करथिलु प्रथमे आमको आसिकी कहिथिले कि केमितिका आमर सार प्रयोग केमिति हबो हार्मोन रा प्रयोग केमिति हबो कोनोसी रोग पोक लागिले आमे ताडू केमिति मुक्ति पाई परिबा एई सब विषय रे आमको बुझाइथिले तेणु आमे यार बहुत सक्सेस रे अछु आगो को भी बढ़िबु आम अराजुआ ग्राम रे आम सहित आम साई पड़िशा कि आम गाँ आखपाख गाँ भी एबे बहुत मैरीगोल्ड करुछंती करिकिना भी सक्सेस भी हेइचंती एबे आम गेंडु फूल केवल ढेंकानाल नुह कटक कामाख्यानगर भुवनेश्वर आदि भी बिक्री चली आमको प्रत्येक सप्ताह रे आम गाँ अराजुआ केवल प्रत्येक सप्ताह रे 20 क्विंटाल पाखापाखि आमको फूल आमे बिक्री करि परछु थैंक यू
मोर टिके पचारियार थिला आपनको
आज्ञा
खाली मु कहि आपण केते खर्च कले केते पाइले मोर आ किछि
कोन कहले
केते खर्च करथिले केते पाइले
आमे जदी 40-50 हजार खर्च करिजु ताहले हमको प्रति गोटे सप्ताह को जदी कि हमरो बाहरी जाउची 10-12 क्विंटाल से अनुसार केजी प्रति हमरो पार्वण ऋतु रे केजी प्रति हमको 100 रु 120 भितर हमको केजी प्रति मिल जाए आउ टिके जेबे ऑफ सीजन थाए कोनोसी पूजा पार्वण न थाए हमको केजी प्रति 60-70 भलिया आमे बिक्री करि पारो
केते सप्ताह एमते हार्वेस्ट करिवे 7 दिन थरे करछंती
7 दिन सप्ताह को 2-3 थर आमे वर्ष सारा फुल करूछु
ने बुझिली जे गोटे थर जो लगेइले
आज्ञा
कहले 50,000 टका खर्च कले से जो 50,000 टका खर्च केते पाइले मु सेटा जानियो चाहूछी
माने केते गुना लाभ पाउछंती आपण
केते गुना लाभ पाइले मु सेटा बहुत पचारि लाभ केते हला 50,000 टका खर्च कले लाभ केते हला
लक्ष 2 लक्ष प्लस
माने 50,000 छाड़ी की लक्ष
आज्ञा
थैंक यू सेति जाने थैंक यू
तमार आपण डबलिंग फार्मर इनका गोटे बड़ सोर्स एटा फ्लोरिकल्चर मैडम जहाँ कहले सुभाषिनी मैडम 50,000 खर्च कर से ऑलमोस्ट 1.5 लाख पाई ग्रॉस प्रॉफिट। मैडम धन्यवाद मैडम आपणकर एक्सपीरियंस शेयर कर जोटा कि आपणकर अलग जो अच्छा आम कमर्शियल ग्रोथ निश्चिंत प्रेरणादायक हम। बर्तमान मुझे मिस्टर जयप्रकाश साहू जी खाली फ्लोरिकल्चर नुहे फ्रुट्स भेजिटेबल्स और फ्लोरिकल्चर कहते जेहेतु आम टाइम बहुत सर्ट आप समय खाली गोटे मिनट खाली आप एक्सपीरियंस पाइबे।
हेलो समस्त को प्रथम जय जगन्नाथ। मो ढेंकानाल सहर आमर स्टेशन बजार पाखे मोर गोटे छोटिया फार्म हाउस अच्छी। मु तो बस एमती माने फार्म हाउस रे बस खुशी खुशी रे करूली बस फुल टिके ये फ्रुट्स वगैरह टिके करूली वेजिटेबल्स। आमर ढेंकानाल केबिके दिव्य सुंदर कर सार सहित भेट हो गला सी सेबेठू बस मत गोटे एडवाइस देले जे आप एत भल सुंदर जगह आप अच्छी आपड़ बस खाली कुंडे फुल कर ये कर किसी भेजिटेबल्स किसी फ्रुट्स किसी फ्लावर्स उपर ध्यान भी दिंतु। तो सर कथार मु माने धीरे 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 प्रति वर्ष किसी किसी करना बढ़ई थी किंतु मुझा मो निज ठाकुर घर पूजा हिसाब से करी निज घर खाइबा हिसाब से शाग सब्जी हो टी भेजिटेबल्स हो पिजुड़ी सजना ये टाइप रो करू करू एत परिमाण मोर माने टचिंग रहीगला मोर फार्म रे मुझे बर्तमान माने कमर्शियल आड़ को भी नहीं पारी। तेणुकरी संपूर्ण सहयोग केबी आम ढेंकानाल केबी के दिव्य सुंदर कर सार को धन्यवाद देवी तांको जोगुर ही सफलता मत मिली। मोर फार्म रे पाखापाखि मोर जेहेतु छोटिया फार्म मुझे बेसी किसी करें तथापि मत सी वार्षिक प्राय 8 ରୁ 10 लाख टका इनकम भी दे पारुछि। प्लस मोर एथिरे भी 10 ରୁ 12 जन नियोजित हो पार्छन्ति परमानेंटली और सीजन टाइम रे मते आउ भी 2-4 जन को भी एंगेज करिया पड़ुछि। यही चाष तो मोर लाइन नथिला किंतु या प्रति गोटे एते आत्मीयता मोर बढ़ीगला सी माने धीरे धीरे मु मते फार्मर मो निजको परिचय देवाई पछेबनी फार्मर ही मुझे कहू भविष्य में मो निजक मु गोटे फार्मर परिचय देवाई धन्य मन करी। थैंक यू जय जगन्नाथ।
अनेक अनेक धन्यवाद सर। आमर कृषक बंधु मानक आप शुणुले जो मैंने निजर सफलतार कहानी आम सहित बांटुले अनेक अनेक धन्यवाद। मुझे चाहिए आम सहित उपस्थित थी चाषी भाई मानक चाषी भौणी मानक गोटे जोरदार करताली पुणी थे। Now we are done with our first session. We are very much thankful to our chairperson Dr. P. Nabinji. We were having our co-chair Dr. S.K. Pallai sir from OUAT Bhubaneswar. We were having Dr. Mahadevya C. from IIHR Bangalore. Thank you very much Rapporteurs Dr. Tanushree Sahu and Dr. Tapan Kumar Pallai sir. Thank you very much ma'am and sir. Moving on now. We will have the next session. As we are running late, we would stick to the time. Ladies and gentlemen, now please welcome the chair for the session, Dr. H.C. Prasanna from ICAR IIHR Bangalore. Please welcome sir with a round of applause. We are having our co-chair, Dr. G.C. Acharya from ICAR IIHR Chase Bhubaneswar. With us, we are having Dr. Deepa Samant from ICAR IIHR Chase Bhubaneswar, and the rapporteur for the session is Dr. A.V.V. Konindya from Chase Bhubaneswar. Please welcome the session chair, co-chair and rapporteurs with a round of applause. गोटे जोरदार करताली सहित सेमानंकु आमे स्वागत जणाइबा। वर्तमान प्रथम स्पीकर जो अछंती, the first speaker for the session, let's welcome Pratibha Rawat from Hembati Nandan Bahuguna Garhwal University, Srinagar. All the speakers are allocated with a time of 10 minutes for the oral presentation and for the keynote presentation, and for the oral presentation we are having 5 minutes of time. We are having our valedictory session at almost at 4:30, so we are already running late, so making it a little faster. The first speaker, Pratibha Rawat. If she is not there, is she virtually? Is she virtually present with us? No. Moving on, Doli Saikia from UPES Dehradun. Okay. Please welcome Doli Saikia from UPES Dehradun. We welcome you to AgriVision 2026. Please go ahead with the presentation. Please stick to the time. Thank you.
Very warm good afternoon to everyone present here. My name is Dolly Saikia, and I'm here to present a piece of my research work on the title Effect of Processing Techniques on In Vitro Protein Digestibility, Anti-Nutrients, and Functional Properties of Selected Plant-Based Foods. So first of all, why protein? We all know that proteins are the building blocks of the body, required for body functioning, immune system, etc. But why plant-based protein? We have been talking about sustainable food system, which is majorly shifting from animal-based diets to plant-based diets in order to decrease water and carbon footprints. But when we look at the protein consumption around the world, India stands at the lowest, and that too, the plant-based protein could not even meet the average daily protein requirement, which leads to protein energy malnutrition, stunting, and high mortality rate. So the key challenges to food security and nutrition are the poor protein quality, that is low protein digestibility of plant protein, and incomplete amino acid profile of the plant-based foods. Also, high anti-nutrient content, which inhibits the protein digestibility and protein quality in plant-based foods, and undernutrition even though food is available. So first and foremost, we have done an extensive systematic literature review within the past 10 years, and very interestingly, we have observed that the emerging or the non-conventional food processing methods are found to have very, very low improved protein quality when compared to the traditional or the conventional food processing methods. So even though the emerging food processing methods are known for their potential benefits, there is still research needed and more exploration needed in terms of protein quality and amino acid profile for the plant-based protein. So these are the selected ingredients: rice, finger millet, chickpea, mung bean, and peanut, based on the systematic literature review. And this is a systematic overview of my research work. The ingredients, rice, finger millet, mung bean, chickpea, and peanut, were processed into flour using soaking, germination, roasting, combination, and roasting. And then they were analyzed for proximate composition, anti-nutrients, in vitro protein digestibility, functional properties, FTIR analysis, and SDS page. So these are the methodology for the processing of Johar rice into flour using soaking, finger millet flour using germination and soaking, processing of the green gram or mung flour using soaking, germination, then tray drying and grinding, chickpea flour using germination as well as roasting, processing of peanut into peanut flour using both dry as well as wet roasting. Then coming to the results, from here we can clearly observe that soaking, germination, dehulling, and roasting, all the processing methods have decreased the anti-nutrient, that is the tannin content, in all the ingredients, that is rice, finger millet, green gram or mung, chickpea, and peanut. Similarly, reduction of phytic acid content using the processing technologies. And of course, on decrease of the anti-nutrients, the protein digestibility has been improved, and the highest improvement of the protein digestibility was up to 92.5%, and the highest increased percentage was more than 20%. So these are the functional properties. The processing has also improved the functional properties of all the ingredients. Here I have shown the water holding capacity. So these are the FTIR analysis. So the change in the intensity of the peaks suggests that protein denaturation and partial protein breakdown, which again validate the previous results. Similarly, this is the FTR analysis of green gram, chickpea, and peanut. So the change in the intensity of the peaks validates the previous results, which is improvement of the protein digestibility. This is the SDS page, which was mainly done to further confirm the impact of processing on protein quality. So the protein bands found approx 25 kilodalton suggests the presence of globulin and albumin, and also the slightly reduction of the bands suggests partial protein breakdown and confirms protein denaturation, protein modification, structure modification, and retention as well. So coming to the conclusion, I would like to conclude my study that food processing induced improvement in plant protein quality by improving the in vitro protein digestibility, reduce anti-nutrients, and also improving functional properties. So by translating these research insights into food applications, we should go for development of high quality protein enriched winning foods or high quality protein enriched porridges and snacks, digestible and protein utilizing food for the elderly man and women. So this is the published data of our research, and furthermore we have developed winning food product and continuing the in vivo protein digestibility and protein quality using animal models. Thank you.
Thank you. It's a good presentation, Doris Aikia. If you have one question, you can take up now.
Yes, let us take one question. Any question, anyone?
We can continue. That is done. Yeah.
Thank you very much for the excellent presentation. For a round of applause for her. Moving on, for the next presentation, please welcome Rokesh Radhakrishnan from Indian Institute of Technology, Kharagpur. And he is going to present on calcium-mediated strategy for rapid acidogenic sludge formation with simultaneous improvement in biohydrogen production. Please welcome Rokesh Radhakrishnan. Over to you, sir. Next up, we have Abha Rawat. Please be prepared.
So good afternoon to one and all present here. So I'm a research scholar from Indian Institute of Technology, Kharagpur. So I will be presenting one of my research topic, which I performed at IIT Kharagpur. So the topic is like calcium-mediated strategy for the rapid acidogenic sludge formation with simultaneous improvements in hydrogen production. So currently we know that there's an emphasis on like energy, water, and food all together like has a nexus together. So with increasing in population, like the pressure mounts on all the three. Like in order to overcome this, like so because of this, like demand of energy and pollution has been like currently glooming up, and like has been pressure on this. So in order to do this, like alternative energy has been like focused on, like among which renewable energies like are like coming up. Apart from this, like the bioenergy like of like hydrogen has been like currently of interest since they are the greener fuel, and the combustion of them gives like water, and they have like high energy content. So among the processes available, like the biological process is like more emphasized using organic feedstocks. So this is where like the like agro-industrial wastes and like other wastes can be used to process and to produce cleaner energy. So among this, like UASB reactor, that is upflow anaerobic sludge blanket bioreactor, is a commonly available like a reactor like where biogas has been produced. So like this is a conventional technique available, but like production of biohydrogen specifically like is like coming up, and like in order to do that, like, currently research has been trending, like where like the biogas setup can be like turned to a hydrogen fuel itself, like thereby like high energy can be produced. But however, they have a disadvantage of long startup period, and sludge overloading. So this disadvantage is prevailing. So this is the overall focus of my work, and research has been done. So initial preliminary operation of upflow reactor has been set up, where a laboratory setup has been given, and the hydrogen production was evaluated. So with increasing time, you could see that the hydrogen production of almost 1 liter per liter was seen. But however, a substrate a conversion of only 77% was observed. And apart from that, during the process, the volatile fatty acids was produced. So comparing to the continuous or the slit tank reactor, the production of hydrogen is less in this. And apart from that, when we studied continuous state reactors study, where the inlet and outlet pumps were given, and then the operation was done. So the production was unsteady and quite low. So how can we overcome this? So as I mentioned, the constraints are for the previous setup was low hydrogen production and longer startup time. So the startup time is long because of the poor seed culture or poor acidogenic culture formation in the reactor. So this has to be avoided. And apart from that, low energy recovery and incomplete utilization of substrate. So in order to overcome this, a feed additive of calcium chloride could be added, so that the inoculum can be fastened up and the sludge process can be improved. So we can produce a acidogenic sludge in a quick time with reduced time, that is, so this process can be done. So in order to do that, in-depth study of initial optimization, variation of calcium chloride from 100 to 500 mg per liter was evaluated, where 400 mg per liter showed highest biohydrogen yield when we compared with the 0% concentration. So also you could see that the biomass content was higher. So this concentration was taken, and initial batch reactor study was done in a laboratory setup, where the hydrogen production of 1.7 liter per liter was observed. So in presence without calcium chloride. But when this was compared with the presence of calcium chloride, the hydrogen production was almost 2 liter, 1.9 liter per liter. So adding a calcium chloride for sure increase the hydrogen yield. And apart from that, the substrate yield was almost 86%, 86 to 96%. So this was observed, and initial kinetic parameters was evaluated. So you could see that specific growth rate was also improved when in the addition of calcium chloride, almost 0.28 was observed when we compare without the calcium chloride, and the production was also higher. So with this point, we need to heighten up the culture, that is the acidogenic culture, to start up the overall USB reactor. So continuous operation was done. So without calcium chloride is a standard control, which I wanted to compare my experimental studies. So without calcium chloride, the continuous study was done, and you could evaluate the dilution factor, that is specific growth rate of 0.2 per hour, gave you the highest hydrogen production yield. And apart from that, the VFA content and everything was evaluated by GC. And then when we compare the system with the presence of calcium chloride, the dilution factor was improved. That is, the specific growth rate of the overall system was higher, up from 0.2 to 0.25. So this enhancement is due to the addition of calcium chloride, where the organisms were interacting together and sludge formation was initiated. So this was observed, and the continuous reactor of the dilution rate of 0.15 was chosen for without calcium chloride. So this operation was done in order to evaluate the quality of the sludge. So parameters were defined, and to see that how the acidogenic consortium are rapidly forming to form a quality sludge to kickstart the overall hydrogen production when we use the USB. So this reaction was done. So as without the calcium chloride, this was a standard, that is a control, which was run, that is a 0.15 dilution rate. It was run for almost 4.5 days. And then with the presence of calcium chloride, 0.2 H per hour dilution rate was done for 4.5 hours, and the sludge was collected in 2 intervals. that is 49th hour and 118th hour. So when we compare without the calcium chloride with calcium chloride, so the content of the proteins were like comparatively higher, and like carbohydrate content were also higher when we compare the system without the calcium chloride. So this corresponds to the fact that like the addition of calcium chloride triggered the secretion of extracellular complexes of proteins and saccharides, and which kind of enabled in forming a flux and which can kickstart the reaction. So this is a mesh network when we compare the sludge. So this is how it looks, and so this further evaluation was done by studying the volatile content present using like with the ratio of MLVSS and MLSS. So this kind of evaluates the quality of the sludge which was formed, so that the sludge which is formed or the flocks which is formed are like without any metal ions. Since calcium I'm introducing, so there is a chance of like calcium cementing within the reactor. So this can again be a potential threat or problem when the reaction happens. So this has to be studied. But however, the quality of the sludge was more higher with the presence of calcium chloride. So the salts were not affecting the acidogenic consortium inoculum itself. So this was evaluated again. So again, like the beautiful flocks of like a bigger size was imaged, so based on that, the image analysis was done. So two systems without calcium chloride and with calcium chloride. So you could see that in the 49th hour, very small flocks are absorbed. In 118th hour, like the flocks were like much more higher in the without calcium chloride. But in the presence of calcium chloride, so the 49th hour and 1/8 hour are almost the replica, like it's the same. So the flock size were higher, and in 118th hour, the flocks were much more bigger. So beautiful flocks were observed, and like which kind of corresponded that the cell masses were like binding together, and like sludge was initiated. And this was done by microscopic image. And then like the size of the flocks was seen. So without calcium chloride, only almost 80 numbers of the flocks were observed when like two samples were analyzed. In without and with the presence of calcium chloride, more number of flocks were observed with higher size distribution. So this could be again like seen the system without calcium chloride and with calcium chloride. And zeta potential was done in order to see the potential of the flocks formed. So it could see that like with the presence of calcium chloride, the zeta was like much more reduced in both 49th and 118th hour. So it corresponds to the like fact that like quality flocks of like a bigger size was formed in a rapid time when we introduce calcium chloride, and this sludge can be introduced for the acidogenic consortia to kickstart the USB reactor. So this is the overall process scheme of this study, and the conclusion is hydrogen production was improved to 20% with the addition of 400 milligram per liter of calcium salts, and the bioflux of 1.5 mm was attained at like 118th hour without hampering the flock quality. The extracellular polymeric substances were improved with the addition of calcium salts again. The protein accumulation were higher, which played a key role in improving the addition of sludge quality, thus avoiding calcium cementing. A rapid flock rated system was achieved using calcium chloride with improved hydrogen production to reduce the reactor startup time in USB. So thank you.
Yeah, good work, Mr. Rakesh. Excellent presentation as well. We can take up one question if we have.
Any questions?
We can go to next presentation if there are none.
Thank you very much. Yet another excellent presentation. A round of applause for him. Moving on, please welcome for the next presentation Abha Raut from Hemwati Nandan Bahuguna Agarwal University, Srinagar, and she is going to present an assessment of nutritional composition and antioxidant activities in foxtail millet. Give it up for Abha. Next presentation is by Titikha Makahari. Titikha Makahari, please be prepared for your presentation.
You can have 7 to 8 minutes of presentation, please. Yeah.
Good afternoon, everyone. My name is Abha Raut. I am PhD scholar from Himwati Nandan Bhagwana Gadwal University. And the topic of my presentation is assessment of nutritional composition antioxidant activities in foxtail millet. So basically foxtail millet is known as Satirica italica, and in the production among millets, it is in second rank after the pearl millet, and globally it is cultivated in marginal and resource poor soil, which make it ideal crop for sustainable agriculture. And apart from this, it is a farmer loving crop due to the short duration and low water requirement. And the problem which I have facing in the Uttarakhand is that the migration, which leads to the livelihood insecurity and agriculture decline and climate stress. In Uttarakhand, the nutrition property of foxtail millet is still unknown in the land races, and therefore the variation in the elevation and the agroclimate regions, the different land races were collected, so it can be given a cultural output. So the objective of my research is to explore nutrition composition and antioxidant potential of foxtail millet land races collected from the different regions of Uttarakhand and comparing them with improved varieties and developed accession. And the second objective is selecting the promising local variety based on their composition, so it can be identify the health benefit and conserving the local germplasm with high nutrient value. These are the materials and methods. I have collected 22 foxtail millet genotypes, which are from the different districts of the Uttarakhand, that is Chamoli, Pauri, Gadwal, Uttarkashi, Almora, Tiri, Gadwal, Rudraprayag. This is the locations which I have shown here. In Uttarakhand, the elevation of the germplasm, the land races soil, which I have collected is from the 1000 to 2000 altitude. And these are my nutrient analysis which I have done, is the functional composition estimation, nutrition estimation, and anti-nutrition content. And now moving on to the result. So here is the ANOVA is presented, where it can be seen that the non-significant relation was founded in the amylose and total antioxidant content, while the other nutrient and antioxidant compound has shown the significant relation at the probability 1%, which suggests that the traits which are showing probability at 1% are driven by the genotype basis, based on the genotype. So this is multiple comparison and a promising genotype based on the nutrient content using the HST test. So here what I have seen, I have written here the promising germplasm. So that vary according to the traits, and there is not a fixed particular germplasm land races which come out here. So it can be said that we have to take the multiple germplasms for the different traits. So this is the correlation coefficient table. Here what I have figured it out during my study is that the iron and protein were linked together, while while the majority of the nutrient were founded good with the majority of genotype were founded good with the antioxidant properties, which are DPPH, FRAP, HRS8, which is known as hydroxyl radical activity, and carbohydrate content, and has shown the negative result with the antioxidant property. So this is the PCA biplot based on the region. So where it is seen that the antioxidant activity, which is DPPH, total phenolic content, total antioxidant content, have shown their major contribution. The promising land races which I have seen during my studies, FMC2, FMC3, FMP3, FMP5, FMP6, FMU3, and FMU4. These are the promising land races from the 18 land races which I have seen. And these, the major trait of these land races are they are in brown in color. And this is the cluster genetic distance cluster diagram. So here I have seen that total 5 clusters were made at the genetic distance 7.25, which is the large wide diversity I have found in the land races of Uttarakhand region. And the conclusion of my my study is that the genetic variation existed in the protein, existing protein, carbohydrate, starch, iron, ascorbic acid, and antioxidant properties, which is a broad indication for selection. And the superior genotype FMP6, FMP5, FMR3, FMC2, and FMA1. And there are some multi-purpose genotypes also, which is FMC2, which can be used for superior, which can be used for physical-functional properties because it has good swelling power and water holding capacity and can be used in the food processing companies. And the implication of my study is that we have identified the nutritionally superior genotypes which are provide valuable donor parents for the biofortification crop, and nutritionally it can these land races will fight with the micronutrient deficiency, particularly for the iron, which is well known for hidden hunger. And finally, but I have seen that these land races are contributing to the sustainable development goal in the sustainable development goal 2, which is zero hunger and good being and well-being, and SSD 12 and SSD 13. And these adoption of these land races will support the livelihood diversification in the Uttarakhand regions and strengthen the local food system. That is my thank you.
Thank you. Good presentation. Thank you. I don't think there are questions. Yeah, I will move on to the next one.
Yes, thank you very much, Ava. Well presented, very well presented. Give her a round of applause.
So we are expecting Minister to be here for valedictory function by 4 o'clock. Please speed up and focus on only the key messages from each slide. Then, detailed discussion on the components of the slides, please.
As the Honorable Minister is going to join us for the valedictory function, we are making it a bit faster. Please stick to the time. Now let us welcome Titikha Makahari. Titikha Makahari from Central Institute of Technology, Kokrajhar. And followed by, we will be welcoming Madhusmita Bal from OUAT.
A very good afternoon to all. Myself, Titika Masahari, research scholar from the Department of Instrumentation Engineering, CIT Kokrajhar. Today I am going to give a presentation on my research work, Evaluation of Modified Indirect Solar Dryers Performance for Sustainable Drying Musa balbisiana cola pulp, which focuses on thermal performance analysis of thermal energy storage material of solar dryer. These are the contents of my presentation. So for drying, I have chosen Musa balbisiana cola, which is known as Atia coal in Assam, and it is found in South Asia. The health benefits of Musa balbisianas are, it is good for eye health, rich in fiber and rich in vitamin C, and it can boost energy. It is good for weight management, heart health, menstrual health, and digestive health. To dry the agricultural products, I have designed modified indirect solar dryer. In MISD, I have 3 main parts, which are collector, thermal energy storage, and drying chamber. And this dryer have capacity of 20 kg. In thermal energy storage, I have used paraffin wax as thermal energy storage material to dry the agricultural product even after sunset, because originally we dried the product during the presence of sunlight, but after sunlight we can't dry the product. Because of that, I have designed thermal energy storage system with thermal energy storage material, paraffin, which can hold thermal energy heat capacity till 2 to 3 hours even after sunset. So these are the list of instruments I have used in designing modified indirect solar dryer. Here I have shown the images of collector, drying chamber and thermal energy storage. So in thermal energy storage, to hold the paraffin wax, I have used aluminum tubes. And sensors are used to sense the temperature, drying temperature, humidity and ambient air. So here I have shown the image of sample drying in open sun drying. And this is the image of a sample dried in modified indirect solar dryer. So I have divided sample in two types. One is treated and one is untreated. Treated is done by blanching. So this is the list of tables I have analyzed, the quality analysis of dried sample after drying. Here in result and discussion, I have shown the thermal characteristics of MISD. So before drying this sample, I have performed the experiment without load to check the thermal characteristics of thermal energy storage material. After that, I have performed the experiment. So in figure A and figure B, we can see that even after sunset, the thermal energy storage material and drying chamber temperature remains still 45 degree to 50 degrees Celsius, which is okay for drying. And here we can see the effect of treated and untreated sample, which effect on color. In table 3, I have shown the water activity, final moisture content, and drying time of article pulp. From this, we can see that treated samples dried faster than untreated ones. And MSD significantly reduced drying time compared to open sun drying. Lower final moisture content and water activity in MASD treated banana pulp, it indicate better microbial safety and self-stability. So based on this table, I have analyzed the quality analysis of MASD treated sample comparing with fresh sample. So this is the proximate analysis of article pulp. From this, we can see that the dried pulp exhibited increased S content, crude protein, crude fiber and carbohydrate content compared to fresh pulp, which indicate improved nutritional density after dehydration. Table 5 shows the bioactive compound content of article 5. Here we can see that the drying significantly increased total phenolic content and total flavonoid content, which may be attributed to release of bound bioactive compounds and moisture loss. And here, antioxidant activity increased in dried pulp, while vitamin C content decreased due to its heat-sensitive nature during drying. And table 6 shows the chlorophyll content and total treatable acidity content of article pulp. According to the quality analysis, the sample dried in MASD showed enhanced nutritional quality, higher bioactive retention, and improved storage stability, which make it more suitable for health benefits and long-term preservation than the fresh sample. In conclusion, I can say that even after sunset, MS controls temperature between 45 to 55 degrees Celsius, and it can continue drying. Energy and exergy efficiency of MASD was 50% and 74%. And MSD shows a short economic payback period of about 1.7 years, means the total cost of MSD was covered around 1.7 years. Overall, from this, we can say that MSD is a cost-effective, sustainable, and farmer-friendly drying technology which is suitable for small and marginal farmers to increase income and ensure food security. These are the reference. Thank you.
Thank you very much, Titika. Thank you for coming, for joining all the way along from Assam. A round of applause for her. Well presented. Any questions, anyone? No? Let's, thank you so much. Let's move ahead. Please welcome Madhusmita Bal from Odisha University of Agriculture and Technology, Bhubaneswar, and she is going to present on role of interspecific grafting in modulating flood stress tolerance in tomato, Solanum lycopersicum L. Over to you.
Respected dignitaries, good afternoon everyone, all the honorable teachers and faculty members. My name is Madhusmita Bal. I am a PhD, I'm a research scholar from OUAT. So to start my presentation, I would like to say something like we all know that climate change, it's no more a future threat. It's a present reality nowadays. And the crops which are, vegetable crops, maybe brinjal, tomato, which are most widely used vegetable crops, that gets hampered a lot. As a result of this climate change, there is irregular precipitation, which sometimes can cause drought and sometimes can cause flooding. So tomato is a crop which is very sensitive to this flooding stress or waterlogging stress, we can say that. So it's really sensitive. So as a result, what happens, the farmers face a huge loss in yield of the crop. What is the solution of this problem? What is the solution to this problem so that farmers can do not have to compromise on yield simultaneously? They can do it on their own, and it should be fast. It should be sustainable. We are talking so much about sustainability and all. So it should be sustainable, it should be fast, and it should be cost effective also. So the answer to this question led to the foundation of this research work, that is role of interspecific grafting in modulating flood stress tolerance in tomato. As I said, my name is Madhusmita Bal. Next. Okay. The problem statement is, as I said, tomato is highly susceptible to flooding. It can maximum withstand up to 24 to 48 hours of stress, not more than that. And the major symptom that happens to be due to this stress is leaf chlorosis, epinastry or drooping of curling of leaves, then root hypoxia and severe reduction in vegetative and reproductive growth. The productivity is severely limited during this rainfall or the soils which is having poor the soil that is having poor drainage, with poor drainage capacity. So it has been observed worldwide that almost the total area, 16% of the total production area of tomato crop is prone to this flooding risk or waterlogging stress worldwide. So this led to the objective of my research work, that is to mitigate these effects. This research work investigate interspecific grafting. As we know, all the solanaceous crops like brinjal, which is, we cannot say that it is tolerant to stress, waterlogging stress, but yes, it is more tolerant than tomato. Because tomato, in case of tomato, it can withstand maximum 20 to 48 hours, whereas brinjal can withstand more duration to this flood stress. So in this research experiment, we have taken 3 varieties like Sorna Sakti, Sorna Samali and Utkala Anushri for this flood tolerance ability as rootstock, and we have assessed different mechanisms like morphological adaptations, for example formation of adventitious roots and different physiological changes that has happened in the plant after grafting and all. So, and my hypothesis was whether these grafted plants are more tolerant to stress as compared to non-grafted plants. The rootstock was taken a brinjal plant, all these 3 varieties, and the scion was tomato plant. The planting material, the scion was Arca Rakshak. As we know, this variety is well known for its disease resistance capacity. And the rootstock, we have taken Sorna Sakti, Sorna Samali and Utkal Anusri. And the stress treatment, there was 3 treatments were given. One was control, that is no waterlogging stress. Next is 3 days of stress and 6 days of stress, that is continuous waterlogging for 6 continuous days. And the observations, different morphological and physiological observations were also taken after recovery, that is 7 days, 14 days and 23 days after removing the stress. Different parameters were observed. And the parameters that was taken, morphological is plant height, leaf area, adventitious root and wilting percentage. Biochemical and physiological parameters that were observed is chlorophyll content, carotenoid content, proline, protein and calcium. And also we have taken different yield measurements like number of fruits, fruit weight, yield per plant, harvest index, etc. So first, I'll directly go to the solution part, the result part, because the plant height, there was high reduction in plant height, but the plant height reduction as compared to non-grafted plants, it was less. It has in the 3 varieties which was taken as rootstock, Sorna Sakti, Sorna Samali, Utkal Anushri. Out of these 3, the Sorna Sakti was outperforming in most of the parameters. In case of there was a very less reduction of plant height, it is almost 18 to 18.9%, whereas non-grafted there was reduction of height is almost 21.7%. And the visual stress indicator, which even the farmer can also himself access that is wilting score and adventitious root formation. Out of the 3 rootstock, the Sorna Sakti variety or genotype, which the grafted plant, which was rootstock was Sorna Sakti, that was having high, it's not exactly wilting score, it's a tolerance score basically, which is measured from 0 to 5. 5 being the highest and 0 being the lowest tolerance. So Sorna Sakti was assessed to be having high tolerance score, which is 5, and simultaneously the plants were also scored for formation of any adventitious roots. In that parameter also Sorna Sakti performed to be higher side, it was 3, which is maximum. And the recovery time was also 7 to 10 days, and most of there was almost 100% recovery for this rootstock. So the leaf area reduction, Sorna Sakti was having maximum leaf area, and the reduction also as compared to the non-stressed plant, the reduction was less, which is 33.6%, but non-grafted plants, there was highly reduction in leaf area, which is almost 59.9%. The key observations were the adventitious root forms exclusively in grafted plants, acting as a critical adaptive mechanism for oxygen uptake. Next was total chlorophyll content as compared to non-grafted plants. Similarly, chlorophyll content reduction was less in Sorna Sakti, whereas in non-grafted plants the reduction was high. Similarly, carotenoid content and SPAD index. SPAD index is also a measurement of, it's a relative measurement of chlorophyll, or greenness of the plant. So that was also, a less reduction in case of Sorna Sakti as compared to non-grafted plants. And proline accumulation, we know that whenever there is a stress condition, there is production of ROS reactive oxygen species. To nullify that, there are different antioxidants which are getting produced inside the plant. So this antioxidant, out of this, proline is one of them, which is a amino acid, but it acts as antioxidant and it helps in scavenging the reactive oxygen species which is produced during the stress condition. So proline accumulation was seen to be high in case of Sorna Sakti. That means it is fighting in a better way with stress as compared to other rootstock varieties as well as the non-grafted plants also. And the rest 2 varieties which were taken as rootstock, their parameter were in between these Sorna Sakti and non-grafted plants. And there is almost has been observed that as compared to non-grafted plant, there is almost 8.5 times increase in proline accumulation in case of grafted plants. The quantitative metrics biometrical profile, when we analyzed, it was seen that the protein content was also high. It is 4.89 milligram per gram, and calcium content, which is the total calcium content, it includes maybe the ion, the bound form and also free radicals, everything. It includes everything, total calcium content. It was found to be 4.8. The lycopene content, which is the major carotenoid pigment which is responsible for coloring and good of the fruit, good quality fruits. So that content was also found to be high in case of Sorna Sakti grafted plants, whereas the non-grafted plants it was less, which is 1.13. The grafting, the key insight was grafting mitigated this decline in protein and calcium significantly, and notably lycopene content in fruits also increased in grafted cultivars as compared to non-grafted plants under the stress condition. So this is a graphical representation of the same, the protein content, calcium content and lycopene content, which is as compared to non-grafted plants, Sorna Sakti is having higher amount. Then let's come to the comparative yield component. In the fruit number, average fruit, yield per plant and harvest index, all these.
You have 2 minutes.
Okay, sir. In all these parameters, the value was, higher for Sorna Sakti. The yield per plant was 224.3, harvest index was also higher, fruit number was also higher. The critical finding was, while yield penalties exist due to stress, Sorna Sakti rootstock substantially mitigated these losses, maintaining reproductive viability, whereas non-grafted plants failed this on this parameter significantly. So statistically, when we observe there are significant difference in chlorophyll retention, very less decline in chlorophyll content as compared to non-grafted, proline accumulation and yield advantage. And the most important practical tolerance indicator was adventitious root, which was identified as the primary morphological mechanism for flood tolerance, and this trait was conspicuously absent in sensitive non-grafted plants. And similarly, biochemical defense system was also very high in case of grafted plants. So the key conclusion was grafting efficacy was verified, that is interspecific grafting into eggplant rootstock significantly enhances the flood tolerance, and the superior rootstock, out of the 3 rootstock that we have used, the superior one was identified as Sorna Sakti. And similarly, resilience and recovery, almost 7 to 10 days after the removal of the stress, the plant got recovered, whereas the non-grafted plants could not. So, and the recommendation was this interspecific grafting can be adopted, the training can be given to the farmers so they can apply this technique, they can be used in their field condition to get a, less, we cannot say that higher yield, but the loss will be less. So that is my presentation. Thank you everyone.
Thank you, well presented, Smita. So if we have questions, we can take one.
Any questions? Okay, if not, let us move forward for the next presentation. Thank you very much, ma'am. Moving on, please welcome Sandesh Bandhu. Pratibha Rawat is there. Pratibha. Sandesh Bandhu is here from Banaras Hindu University, Banaras. Next up, please be prepared.
So you have got 7 to 8 minutes. Just focus on the key messages, okay?
So, good afternoon to all of you.
Hello.
Good afternoon to all of you. Myself Sandesh Bandhu, Senior Research Fellow, UGC from Department of Geography, Institute of Science, BHU. So the topic of my presentation is tradition in transition, changing cultural practices of Baga PBTG. So as we know that India is known for its scheduled tribes, tribal communities, and we have approx 8.6% of the tribal population if we compare it the total population of the country. And there are so many PBTG communities in India. So there are 75 PBTG communities in India. Those are highly vulnerable communities. So this work is related to Baga PBTG community, and so basically this is my study area, Singrauli district, Madhya Pradesh, and my study locations are basically all 3 blocks of Singrauli district. So the main objective of my study is to assess the nature and causes of cultural loss in Baga tribal community of Singrauli district, and to propose recommendations for cultural preservation in tribal communities. So basically here these are my variables: tribal food culture, so traditional deities and traditional folk songs and dances. So there are we can see that only in out of 400, only 37 households know the traditional food culture of Baga tribal community. And we know that Baga, Gond, these tribal communities known for its millets and other food grains. And in traditional deities, there is a sharp decline. Only 96 households aware of traditional deities. And in traditional folk songs and dances, only 80 households are aware about all these things. So it is showing that there is a cultural loss or cultural erosion in the Baga PVTG community. So it is my block-wise Baga population in Singrauli district based on secondary data PM German survey, and it is my final sample size and number of selected Gram Panchayats. And these are all the 39 Gram Panchayats where I conducted my field survey. So this work is totally based on primary survey, key informant interviews, focus group discussions, and door-to-door surveys. And it is my sampling method for selection of sample size. It is Taro-Yamane method, and on the basis of this sample calculation, the sample size is 400. And it is my methodological framework of this whole work. It is profile of respondents. So if we understand the cultural loss in Baga community, we can say that in food, in deities, in folk culture, there is a sharp decline. Only 9.25% of youth aware about traditional tribal food culture. Only 24% youth is know about traditional deities, and only 20% know about their folk culture. So currently Government of India is trying to preserve this tribal culture by documentation, by organizing different type of programs in different regions of India. So it is basically the calculation of cultural continuity index, which is very less 17.75%, and cultural loss ratio, which is high 82.25%, and this calculation is based on this table. So what are the main reasons? So basically modernization, migration, youth's lack of interest, lack of documentation, low availability of cultural practitioners, social stigma, and lack of market support. These are some major causes for this cultural erosion or cultural loss. And these are some pictures from my field survey. And as we know that she is Lahari Bai, and she is known as Millet Queen of India, brand ambassador of millets in India. She was one of my key informant during my survey. And in my study area, the kodo millet is very popular. But nowadays, we can say that due to cultural loss or cultural erosion, it is hard to find these crops. And these pictures are from, and we know that Lahari Bai is famous for her seed bank. So these pictures are from her seed bank, and her seed bank is in Dindori district, Madhya Pradesh. And these are some pictures from focus group discussions in my study area with villagers, sarpanch of different gram panchayats in Singrauli, Madhya Pradesh. And these are some cultural practitioners, folk dances and music, and he is Padma Shri Arjun Singh Dhurve. So like Lahari Bai is trying to preserve the food culture of tribal communities through her seed bank, and same here, Padma Shri Arjun Singh Dhurve sir is trying to preserve the tribal folk art and music of Baiga community, and that's why he is awarded by Padma Shri. So these are some articles which is related to that Lahari Bai's works. So what can we do? It is important to expand the seed bank work of Lahari Bai. So location selection, seed bank setup, monitoring, promotion and assessment, and after that expansion. So by using these model, we can expand the work and plan of Lahari Bai. And again, after this expansion of seed bank model, Sadat model of tribal tourism also enhance the empowerment, economic empowerment in tribal communities. These are some pictures of surrounding environment of my study area. And some of works are also here from related to cultural loss in tribal communities. So if anybody want to study details in tribal communities cultural erosion, so they can go through these works. So at last I can say that cultural erosion or cultural loss is a huge problem, especially in case of food culture, tribal deities, tribal songs and dances. And government is also trying to preserve this culture by promoting different programs, different events. And it is important to preserve these tribal culture of different scheduled tribes of India. Thank you.
Thank you very much, Sandesh. A round of applause for him. Very well presented and indeed excellent work done on community-based cultural practices. Let us have a round of applause for him. Any questions, anyone? Any questions? No? Okay, thank you. Thank you very much. Please be seated. Moving on, now please welcome for the next presentation, Pratibha Rawat from HNBG University, Srinagar. And she is going to present on integrating sustainable agriculture and livelihood diversification for rural development in Himalayan regions. After this, Shrija Priyadarshini from OUAT Bhubaneswar. Please be prepared. After Pratibha's presentation, we will be welcoming Shrija Priyadarshini from OUAT.
A very good afternoon to each one present here. My name is Pratibha Rawat. I'm a research scholar from Department of Rural Technology, Hemanti Nandan Bhogna, Gadwal University. Topic of my study is integrating sustainable agriculture and livelihood diversification for rural development in Himalayan regions. As we are well aware that Himalayan ecology is a fragile ecology which has also limited and scarce land. It is also facing the problem of rising climate uncertainty, which makes farming closely to livelihood constants. For this, farmers are relying on two kind of common practices, which is indigenous agriculture practices and scientific agriculture practices. In terms of indigenous agriculture practices, practices such as land preparation, soil and water management, and post-harvest storage are practiced by farmer. In terms of scientific practices, farmers are adopting it selectively, which shows the immediate result in cases of pest management or seed selection. So this sort of models which is being practiced in is Himalayan region shows the integration rather than replacement. But it is also to be noted that due to rising climate uncertainty and other factors, it is also leading to vulnerability, which not only depends on environmental stress, but also on adaptive capacity, such as institutions present there, natural resources management system, and technology adoption, for which farmers are adopting as an adaptive strategy as crop diversification. So through this study, we will understand how indigenous practices, scientific inputs, diversification interact together in promoting sustainable agriculture. The study area for this study was conducted in Nagaon block of Uttarkashi district, Uttarakhand. For this study, 3 objectives are studied. First one is to assess farmers' adoption of indigenous and scientific practices. Second one is to analyze livelihood and crop diversification as adaptive strategy. And third is to examine how climate and environmental stress are associated with adaptive capacity and livelihood security. The methodology was adopted as the study area was divided into 3 altitudes, 1,000 to 15,000, 15,000 to 2,000, and above 2,000 meter. Then the study was conducted in 10 villages, taking out 283 households. So the first analysis was done on perception based of 2 prominent indigenous and scientific agriculture practices, which shows that scientific agriculture practices are, although technologically efficient and improve productivity, but indigenous practices are deeply rooted in farmers' community. As I've earlier mentioned, that farmers are using indigenous practices for land preparation and other methods. Only in case of pest management and also in case of seed selections, farmers are shifting towards scientific inputs. Then in-depth study of indigenous and scientific soil management practices as well as water management practices were done, which shows that traditional organic practices like FIM, contour farming, stone burning, these are used by farmers. Mulching and agroforestry are moderately used by farmers. And other modern soil management practices like soil testing, etc., vermicomposting, biofertilizer, they are less adopted by farmers. Similarly, in water management practices, it was observed that the hill farmers are still relying on traditional system of water management, and the modern water management practices like rainwater harvesting, percolation pit, etc., they are rarely adopted by farmers. But it is also seen that modern irrigation practices like drip and sprinkler irrigation systems are recently being used by farmers as they are diversifying their traditional agriculture to cash crop based and other crops. Then another thing was notified that classification of livelihood diversification through number of livelihood sources, where it was categorized under into low, medium and high. It was studied on the basis of altitudinal range, where we can see that in altitude range 1000 to 1500 and 1500 to 2000, the dominant livelihood patterns are traditional crops and modern crops plus horticulture, livestock. But in above 2000 meter, we can see that tourism has been added as one of the dominant livelihood pattern because of the harsh climate and limited agriculture in the upper Himalayas. Lastly, a study on climate stress, adaptive capacity and livelihood security was done, where different variables were taken. which shows that it was studied through Pearson correlation matrix. This shows that climate and environmental stress plus soil degradation influence adaptive capacity that determines the livelihood status. So adaptive capacity act as a bridge between stress and livelihood. So livelihood condition in hill is not just shaped by climate and soil condition, but instead it is more or less dependent on adaptive capacity. So key gaps that were observed in the study was that there is a gap between rich indigenous practices that are followed by farmers and the formal recognition that is given to these indigenous farmers. Then, as farmers are reliant on traditional soil and water management practices, it is important that for their regular maintenance and technical backing, the financial support is to be given. Another is that the scientific soil and water management practices are not properly transferred to the farmers due to lack of extension and training. Also, the government schemes and government departments are currently working in isolation. The need is to have an integrated support system, or they need to work integratedly. There's lack of continuous technical guidance, and one of the most important gap is the follow-up and adoption. As techniques that are transferred to farmers, it is rarely, follow-ups are rarely taken. So way forward is that, as I earlier mentioned, it is important that it is important to integrate indigenous knowledge and scientific extension through policy and programs. Single converted framework is to be adopted where different departments come together and align with each other. Restoration of traditional and soil water conservations are to be done. Technologies that are tailored to the designs of hill farmers that should be practiced, and there it is very important to strengthen the institutional presence and training. These are some of the pictures from data collection. Thank you.
Thank you very much, Pratibha. The floor is open for questions. Anyone, any question? Okay, thank you very much. Please be seated. आम गहन चाषी बंधु मानक अनुरोध करी कृषक बंधु मानक अनुरोध करी किसी समय आम उद्यापनी समारोह आड़ को जावा आपण मैंने आम सहित सामिल होगापी आप समस्त अनुरोध. नाउ मूविंग ऑन, प्लीज वेलकम श्रीजा प्रियदर्शिनी फ्रॉम OUAT Bhubaneswar. You have got 5 minutes. Please stick to time. Thank you.
You don't have to elaborate an introduction part. Straight away go to your work and then the conclusions, results and the conclusions.
Next presenter, please be prepared. After Srija's presentation, we will be welcoming Madhu Chanda Mishra. Is he there? Madhu Chanda Mishra. No? Sayan Sagnika Mahapatra from Sri Sri Universities. Sayan Sagnika Mahapatra. Jagmohan Dalmia. Jagmohan Dalmia. Is he there? Okay. Deepsika Jena from OUAT. Deepsika is there. Okay. Suraj Malik. Suraj Malik. Suraj Malik is here? No. Madhusmita Bal is over. Her presentation is over. So Suraj Malik is not here. Shrija is there. One more time, let me ask. Madhu Chanda Mishra. Sayan Sagnika Mahapatra. Jagmohan Dalmia. Deepsika Jena. Suraj Malik. Deepsika is there, okay.
Yeah,
only one presenter is there.
You can have 10 minutes.
First of all, good afternoon everyone. It is my pleasure to present my topic, nutritional profiling and analysis in amaranth germplasm. So, today in global there is lot of changing environment like climatic change, food insecurity, and malnutrition and zero hunger. So what we can do? We should do search for the better and alternative crops, that too underutilized crops, and it is essential to meet out the zero hunger malnutrition, which is goal of sustainable development goal of United States. And for this reason, we know that in ICMR in India, that is 400 gram of vegetable should consume per person per day. And among these recommendation, 100 grams should be leafy vegetable. So this recommendation clearly shows that how much important of a leafy vegetable for our daily intake of nutrients. So in this study, I have evaluated Amaranthus germplasm, that is 57 Amaranthus germplasm with 3 check varieties, that is Pusa Kiran, Arka Nilachal Ruchita and Arka Nilachal Bansi, and with 2 contrasting seasons, that is winter season as well as summer season. We know that Amaranthus is known as nutrient-rich superfood, and they're having different mineral nutrients like NPK and micronutrients, all this, and high in protein, carotenoids, and these are having natural pigments and also antioxidant properties. And with this, and we know that in Amaranthus succession there are a lot of variation among this, and we know leafy vegetables also accumulate toxic heavy metals which is harmful to health. For example, these are my 57 leafy Amaranthus line that I have already told that 3 checks are there, and I have analysis macro and micronutrients as well as heavy metals. And the variance analysis shows that the xenotype and environment, that is significant results shown, and majority of the nutrients are shown significant result. And also this is the average performance. We can see that nitrogen content is varied from 2248.49 Ng per 100 gram to 4730.74 Ng per 100 gram. There is a huge variation among those accessions, and these are the genotype I have found that these are for multiple traits. For example, indigenous collection 0647414, and likewise IHR BAM 300 also, they have multiple traits. And it is also imperative to study the heavy metals as with corresponding to the FAO and WHO limits. So I have found that the upper line is for a winter season and this is for summer season. And in winter season, the arsenic, cadmium and lead content is higher than the FAO, WHO safe limits. But we got some of the genotype, the heavy metals is not found. Some of the genotype also there, which is means heavy metals is not found. And in summer also, arsenic, cadmium and interestingly, lead content is much more higher in summer season as compared to the winter season. And the cobalt, chromium and nickel in winter as well as the summer season, they have found much lesser with corresponding to the FAO and WHO safe limits. So conclusion is that the substantial genetic variation is found with diverse germplasm for macronutrients, micronutrients, and the strong influence of gene to E interaction is there. So we need further evaluation of multi-trial and multi-location. And the heavy metals were not detected some of the genotype. I have covered only some of the genotype here. Then the comparative analysis should be for the toxic heavy metals observed in the study with corresponding to the FAO, WHO safe limits. And in the end, we should search and go for the alternative crops, that too underutilized vegetable crop, because we know that vegetable is much more important for our life because they gives us a healthy and balanced diet. So yes, thank you so much.
Thank you, Srija. Good presentation. If you have a question, you can take one. Yeah, please go ahead.
Ma'am, for heavy metals, MPAS is there, and that selenium digestion method is there. So, MPAES, microwave plasma emission spectroscopy.
Yeah, if there are none, you can move on to the next one.
Thank you so much. Please be seated. Please welcome Dipsika Jena from OUAT. If other participants are not there, then she is the last presenter. Madhuchanda, Sayan, Sagnika, Jagmohan, Suraj, and okay, that's it. Anyone is there? Okay, please continue.
A very good afternoon to the juries and all the participants. I am Dipshika Jena. I will be presenting my MSc research work, which was done on evaluation of walnut cashew genotypes on quality and yield attributes. So as we all know, cashew is a very important export-oriented crop. Despite having the largest area in Odisha, the productivity is extremely low. So for my research work, I concentrated on using walnut cashew genotypes. What are these walnut cashew genotypes? These are genotypes which have a nut weight more than 7 gram, and they have premium kernel grade, which fetches very good market in the export. Also, large size nut alone cannot compromise yield. So it indicates a yield and a quality trade-off. Hence, identification of walnut cashew genotypes combining both yield as well as the quality attributes is very essential. These were my objectives, was to evaluate the growth and yield attributes of the walnut cashew genotypes, was to assess the qualitative attributes of cashew apple and kernel, and to identify the superior walnut on per se performance. My experiment was done in Cashew Research Station of OUAT for the year of 2022 to 23. My experimental material were 20 walnut cashew genotypes, and the experimental design I chose was RBD with a spacing of 6 into 6 meter. These are some of the parameters studied, and today I will only focus the important ones. Coming to the growth attributes, the 20 walnut genotypes showed several variation in terms of growth attributes such as plant height, canopy spread. Next, coming to the nut yield. On the basis of nut yield, I identified the genotype T as the best with a nut yield of 3.44 kg per hectare. It also had appreciable amount of qualitative parameters. Coming to the quality attributes of cashew apple, all the 20 genotypes showed a lot of showed a consistent variation in TSS and ascorbic acid, which focused that the apple sweetness was good for processing as well as value addition market. Coming to the kernel quality attributes, all the genotypes showed very good range of protein and carbohydrates, which focuses how walnut could be a potential candidate in the cashew export market. In my research, I identified genotype T being the best in nut yield. It has the highest nut yield of 3.44 kg per hectare. The nut yield as well as the nut size and shelling were also appreciable. The scope for further evaluation, although my evaluation was completed till the second harvest before releasing of the variety, as per the variety release norm, the evaluation must be done till the sixth harvest. As I said, multi-locational evaluation as well as multi-year evaluation is needed before recommending this genotype for commercial use. So significant variability was observed among all the 20 genotypes. The yield and quality exhibited independent variation. Out of all, the genotype T was the most promising in terms of nut yield, but further evaluation is recommended before its commercial cultivation. I want to thank my MSc guide and my PhD guide for their help and all the staff of the Cashew Research Station. Thank you.
Thank you very much, Disika. Give her a big hand. The floor is open for questions. Any questions? Anyone, any question? Thank you very much. Excellent presentation. Kindly be seated. Anyone else yet to present? No? Okay, let us have the concluding remarks from the chairperson.
Thank you, one and all. We had 8 presentations. They were all excellent, nicely presented. One of the important things that we need to learn is sticking to time. I think most of the speakers stuck to their time, which is a welcome development, because most of us waste a lot of time in deliberating on the introduction part, the impacts and other things, rather than focusing on the results and what we did. I think you all did really well in that regard. The content of the presentations were also nice in terms of the methodologies followed. They were all adequate, and also the results were nicely presented with graphs and figures. There are definite good outcomes that can be taken forward in multiple presentations. I wish you all the best of luck in your career. Thank you so much.
Thank you very much for effortlessly chairing the session. We are very much thankful to our co-chairs, both the co-chairs, Dr. G.C. Acharya and Dr. Deepa Samant, and the rapporteur for the session, Dr. A.V.P. Konindia. Thank you very much, everyone, for your valuable presence, patience hearing. Thank you very much for your participation, everyone. पुणी थे चाषी बंधु मान अनुरोध करेंगे आपण मैंने उद्यापनी समारोह में सामिल हेबे. It is an honor to welcome each one of you to the valedictory function, which will be happening in a while. Please join us for the valedictory ceremony. Thank you very much once again. Thank you very much, everyone. We will take an exit and let us get prepared for the valedictory ceremony. Thank you very much.